I'll go ahead. We've got a lot to cover, so I'll go ahead and get started. I did have a nightmare earlier this morning that I had 70 or 80 slides to cover in 20 minutes, but I've made that mistake before, so we won't try to do that today. We'll just hit the highlights and look at some of the prevailing trends in temperatures and heat, especially across Florida, the Southeast, and also some of the larger scale trends. So we'll go ahead to the next slide. And this was just my intro slide, so we can move ahead to the next one. And the first trend we need to talk about is that of increasing greenhouse gas concentrations. Here is the world famous Keeling curve, where a researcher, Charles Keeling, with Scripps Institute, back in the mid-1950s, set up a laboratory on the top of Mauna Loa in the Hawaiian Islands to very carefully measure the concentration of carbon dioxide in our atmosphere. And it's a very representative sample, being isolated in the middle of the Pacific Ocean and away from any population centers, very representative of the global concentrations of carbon dioxide. And here we see the record from these observations starting in the mid-1950s, when CO2 was at about 315 parts per million. We see since then, with the continued industrialization and development across the globe, an exponential increase in the concentrations of carbon dioxide. We're at 415 parts per million or so, and the rise continues basically unabated. What this graph doesn't show is, if we look, scientists have looked at ice cores from Antarctica, where they drill down thousands and thousands of feet, and they can actually go back in time hundreds of thousands of years and extract samples of the atmosphere from the tiny air bubbles that are trapped in these ice cores. And looking at these records of carbon dioxide concentration going back 800,000 years or even more, the current level in our atmosphere greatly exceeds any level in the previous 800,000 to a million years. So that predates the advent of human civilization. This ice core record encompasses 4 or 5 cycles of ice ages and warm interglacial periods. And right now, our carbon dioxide concentrations exceed anything in these ice core records. So this is what we've done to the atmosphere. It's the result of human activity and the burning of fossil fuels. A question I often get is, what about volcanoes? Don't they contribute also? Well, yeah, if we look back way back in time at like the Permian extinction, when most of Siberia was covered with basalt flows, yeah, volcanoes contributed. But in the modern era, it's just a small fraction of what we as humans are contributing by burning fossil fuels. So next slide, we'll take a look at the global temperature trend. Again, a graph I think most of us have seen. There are 4 or 5 centers around the world that track global average temperature using all the surface instrumentation we have at our disposal, going back over a century or more, and also ocean observations. And what we see here on the left is this graph of global average temperature annual, and we see a steadily increasing trend since about 1900, or the dawn of the industrial age. What's really alarming on this graph is, if we look at the last 6 years, each of the last 6 years have been among the 6 warmest on this global record. And that includes 2020, which was second warmest, only trailing 2016, when we had the monster El Nino. On the bottom graph, what it shows is this warming is not uniform across the globe. Some areas experience more warming than others, particularly the Arctic is warming at twice the rate of the rest of the globe, but also the high latitudes of Asia and North America see more warming than the tropical areas. One thing I do want to point out is if you look at the Southeast United States, Alabama and Georgia, there's one pixel that's actually blue that shows a little bit of a cooling trend during the 20th century. And this was known as the global warming hole, the one place in the globe that was not seeing this overall warming trend. But as we'll see on our next slide, since the 21st century, that hole has closed shut emphatically. So we'll go on to the next slide. Uh, this shows US and Florida temperatures. And if we look at the graph on the bottom left, this is a graph of Florida average temperature, annual average temperature, smoothed with a 5-year running average. So what this shows is those last two dots over on the far right are the last 2 years that our 5-year average of temperatures here in the state of Florida is now nearly 2 degrees Fahrenheit warmer than any other 5-year periods since 1895. So here in Florida in the Southeast, we've really caught up in the 21st century, especially over the last 5 to 7 years. Some interesting statistics. If we look at Florida's statewide temperatures, 65 out of the last 69 months have all been warmer than average. And actually, this is a little older slide. We can add about 3 or 4 months to those totals. So that's nearly 6 years with nothing but above average monthly temperatures across the state. This included a run of 31 months in a row, or nearly 2.5 years without cooler than average temperatures. Only December of 2020 broke that streak. Also includes 8 or 9 months of record warm monthly temperatures. And curiously, or actually it's consistent with the theory and with the physics, it's our overnight low temperatures that are affected more than the daytime high temperatures. And just to show that Florida is not alone, the top map there shows the same 5-year running average and the historical ranking of the last most recent 5-year period across the country. And all these climate divisions shaded that dark red. The last 5 years have been the warmest on record since 1895. So the Southeast is quickly caught up, and we're seeing the warming that the rest of the country and the world has seen in recent decades. On the next slide, we'll just take a quick look at 2020 temperatures across the United States. And this map shows the historical rank of statewide average temperatures since 1895. And things that stand out, no state in the lower 48 was below normal in annual average temperature. All those shaded the dark orange are in the top 10 warmest years on record since 1895. And curiously, no state set an all-time record for warm temperatures. However, there were 10 states ranked second warmest. So it just continues this recent trend of warming across the Southeast and the US in general. So we'll go on to the next slide. And I talked about nighttime temperatures warming more than the daytime high temperatures. And if we look at daily records that have been set across the state in the same 5 to 10 year period, there have been twice as many record warm overnight minimum temperatures than there have been afternoon high temperatures. And just to show an illustration of the effect of some of these warming overnight temperatures, here I show a similar graph of summertime nighttime temperatures since 1895 for North Florida. And we see it was fairly steady till about 1990. But since 1990 or so, we've seen an increase of nearly 2 degrees Fahrenheit in overnight warm temperatures. Some of the results of this is elevated soil temperatures, peanut production and yields have been down, especially in 2018, as much as 30% across North Florida. Some agronomists think these warm overnight temperatures and soil temperatures are affecting the physiology and reproduction of these plants and cotton and other row crops. overnight temperatures, cumulative heat on livestock, and also human health, heat-related illness and stroke, which Dr. Oegio will speak more on following me. So we'll go to the next slide. So we've been mostly talking about average temperature now. So why do changes in the average matter? Well, it's not just the average that's changing, it's the whole distribution of temperatures that's also changing. And this can be illustrated by this bell shape or Gaussian curve and distribution. And we see as temperatures warm and there's changes in the average. Now, the hot extremes are 2 to 3 more times likely, and also the cold extremes 2 or 3 times less likely. So these changing average temperatures, it's a good way to measure it, but it also affects the changes in extremes even more. So we'll go to the next slide. And we'll hear a lot about this today from other speakers, but let's not forget there's also land use, land surface changes that affect local temperatures, including mostly the urban heat island effect. And real quickly, the urban heat island effect is that compared to the natural landscape, once we start developing and take down vegetation and canopies and replace it with asphalt and concrete structures, they hold a lot more heat than the natural landscape. So as urbanization increases and spreads, we get an increase in temperature in the local climate. And this map was from a study by Marshall Shepard at University of Georgia. And this was a unique study that it didn't only look at the urban centers, but it also looked at the effect of urban sprawl. And with his study, he shows that Southeast Florida is the most affected area in the entire United States, with a contribution of nearly 2 degrees Fahrenheit or 1 to 1.5 degrees Celsius in increasing temperatures just from urbanization and this urban heat island effect. Now, one other important thing to keep in mind about this effect is, yes, it affects the local temperatures and increases local temperatures. But if you're looking for a temperature trend over several decades, it's the increase in urbanization and the addition of more and more development that will cause an ever increasing trend. If populations are relatively stable, the trend should level off. And in fact, in Southeast Florida, it's been a lot more stable than it was the second half of the 20th century. So we can't attribute all of this recent warming in the last 5 or so years to the urban heat island effect. So we'll go to the next slide. Start taking a look at the occurrence of extreme heat. And I'll use the Miami International Airport, the weather station there, to kind of demonstrate all of this. But the top graph just shows the number of days with a high temperature of 95 degrees or more since about 1940. And what we see is prior to 1980, most years never saw temperatures of 95 or greater. Some years had a few days, but most years did not have any occurrence at all. But since 1980 or so, it's been nearly a yearly occurrence. The record was 15 such days in 2019. Actually, 2021 has been a little bit cooler than the previous 2 years. So we've had a little break from these extreme temperatures this year, but overall you see a trend for an increasing number of days at 95 or greater. Now, at the bottom graph is an interesting bit of climate trivia. Only once on record has Miami International Airport seen 100-degree temperatures, and that was in 1942. And the reason for that is Southeast Florida is surrounded by water. We have the Gulf Stream, which is warm, but we also have the afternoon sea breeze. And then as the summer sets in, we have the easterly trade winds, which really moderate the climate from these really extreme temperatures in the 100s. Temperatures in the 100s are much more common across North Florida, South Alabama, and South Georgia. Next slide. So now let's talk about heat index, which is a way of combining the effects of humidity and temperature. And humidity is important because humans cool themselves by sweating, and it's the evaporative cooling from this sweat that provides the cooling mechanisms for our bodies. The higher the humidity, the less efficient the evaporation is, and the less we are able to cool ourselves through sweating and evaporation. So quick review of heat index, but this graph on the bottom right is from Brian McNulty at University of Miami, and it just shows the number of hours with different thresholds of heat index, 90 degrees, 95 degrees, and 100 degree heat index. And we see with all of these, there's been a pretty significant increase and a rising trend since about 1990. So we see, just like that bell-shaped graph shows you, as the average temperature increases, the occurrence of these extremes, especially in heat index, are occurring at the same time. So on the next slide, we'll take a closer look at heat index. That previous graph only showed heat indices of 100 or more. This one, if you look at the orange tops on these bar graphs, shows the occurrence of more extreme heat index days with thresholds from 105 to 109, and also greater than 110 degrees. And what we see is there's a lot of year-to-year variation on how many of these extreme days we get. This record doesn't go back past 2005, so we can't get a real good feel of the trend, but it just shows you how often these really extreme heat indices can be reached in the Southeast Florida area. On the next slide, we'll talk more about these warm nights, and this is really a very stark analysis here. The map on the top right is from the U.S. National Climate Assessment that just shows the number of nights that they consider warm with a minimum temperature of 75 degrees Fahrenheit or greater. And we see it's fairly common down in the Southeast Florida area, anywhere from 50 to 100 such nights a year, much less common as you proceed north and get up into Alabama and Georgia. But if you look at the bottom graph, this is again from the Miami International Airport, and we see we've gone from an average of around 50 such nights at 75 degrees or greater back in the 1940s and 50s, to now we're running over 150 nights, over a third of the year, with such elevated nighttime temperatures. So really a stark change in the number of warm nights we've seen across the Southeast Florida area. And on the next slide, we'll take a look at some of the projections, the model projections from the U.S. National Climate Assessment, where they show the projected number of such warm nights, both for the mid-21st century and also for the late 21st century. And with the higher emissions scenario on the top, and also the lower emissions or on the bottom. And what we see is, especially with the lower emission scenario, not necessarily a big change for Southeast Florida, because we're already running at 150 nights or more at 75 degrees or greater. But we see, especially as we get later in the century and with a higher emissions scenario, that number greatly increases across North Florida, the rest of the Southeast United States. So on the next slide, I don't want to neglect extreme cold temperatures. And going over this real quick, John Attaway had identified a dozen or so really record cold spells that had catastrophic impacts on the Florida citrus industry. And we see they kind of come in clusters. The late 1890s had several really damaging freezes that really impacted North Florida and ended citrus production there. And then a lot of us will remember the 1980s, when we had a series of very severe winters from 81 through 1989. Also, we don't see many of them in the more recent times. So we'll take a closer look at that on the next slide. First of all, I want to point out probably the harshest severe event ever in our state was in 1899, February 13th. We set the state record of -2 degrees in Tallahassee. Here I have an iconic photo of a snowball fight on the stairs of the old Capitol. Uh, Freezing temperatures across most of the state. Key West and Jupiter, Florida were the only stations that did not record freezing temperatures. It begs the question, with this changing climate, is a severe cold event like this even still possible? Well, the correct scientific answer is yes, it's still possible, but a lot less likely, a lot lower probabilities. Personally, I'm not sure in the next several generations we'll ever see -degrees in the state of Florida. So on the next slide, we'll take a closer look at more recent history. And similar to the other graphs, this is for the Miami International Airport and shows the number of days or number of nights with temperatures of 40 degrees or less. And as we see the early part of the record, actually through the 1990s, it was a fairly common occurrence with up to 5 or even 10 nights of 40-degree temperatures or less at Miami International. In more recent times, almost all the years have no occurrences of 40 or less. The last really severe winter was in 2010 when we had really an extended cold spell or a series of very cold air masses impact the state, had 7 nights of 40 degrees or less. But since then, we've had only 1 night, and that was in last year in 2020. So we'll go to the next slide. This is just another example from Brian McNulty that shows these warming temperatures affecting not only the land areas, but also the coastal waters. This is an analysis of water temperatures in Biscayne Bay. And the orange dots show the record monthly water temperatures at this station. And we see most of the monthly records were set in the last 2 years. Here, this year in 2021, we actually spent 3 months in a row with the average water temperature over 90 degrees Fahrenheit. So big implications to coastal health, seagrasses, marine life, even corals. So we'll go to the next slide. We can't forget climate variability here in the state, especially tied to the El Nino La Nina cycle. These satellite images just represent the vast warming of the equatorial Pacific during 2 of the major El Ninos of this century. We'll go to the next slide. But one that really has an impact on Florida is the opposite phase, La Nina, where that same area is colder than normal in the Pacific. And it usually leads to a jet stream pattern like we see on the bottom that leaves Florida and the Southeast United States warmer and drier than normal. However, the El Nino La Nina cycle primarily impacts our winter weather from November through March. So it's really not much of a player when we're talking about extreme heat and summer temperatures. So with that, we'll go to the next slide and wrap up some take-home messages that global, national, and statewide temperatures continue to rise with increasing greenhouse gas concentrations. Land use and land cover, particularly urbanization, also contribute to rising temperatures. Changes in average temperature lead to amplified changes in the extremes. And as we saw, overnight minimum temperatures are warming more than the daytime high temperatures. And what I didn't go into in depth is the milder winters we've seen are leading to more pest and disease for crops and agriculture, and also the spread of invasive species further north in the state. So with that, I think I'm done, and I'll turn it back over to Lauren.
Great, thank you so much, David. You are a wealth of information and knowledge. Really appreciate all of that. So we do have a few questions before we move into our next presentation. If you just want to stop sharing the screen for 1 minute. So the first question, David, is you talked a little bit about, you showed the slide about how marine temperatures have been increasing, and particularly, I think you mentioned that this last year were some of the warmest on records. How is that affecting, if at all, land temperatures and humidity?
Oh, that's a great question, because it addresses why are overnight temperatures warming more than the daytime highs, and that's certainly part of the problem is increasing ocean temperatures in Gulf of Mexico surrounding the state uh, have led, just by their proximity, led to warmer overnight temperatures. These land use and land surface changes like urbanization are felt more at night when the atmosphere is more stratified and stable and traps the heat near the ground much more than during the day. Also, we've seen an increase in humidity, both with the warming ocean temperatures and just with the warming atmosphere. And a more humid atmosphere is less efficient at radiating heat away at night. So that's contributing to these warm overnight temperatures. And then also just, we're also seeing the whole background climate is warming. And so that's contributing. So that's part of the four main factors that are really affecting the overnight minimum temperatures.
So would you say then also that humidity is projected to continue to increase as well?
Yeah, absolutely. Because as the atmosphere warms, a warmer atmosphere can hold much more water vapor. And so, yes, all the theory and modeling studies show that humidity will continue to increase as temperature increases.
Can you talk a little bit about how increasing heat correlates with rainfall event intensification in our region, if it's correlated at all?
No, that's another great question, especially further north, inland, North Florida, Georgia, Alabama. During the summertime, the extreme heat events were pretty strongly correlated with lack of rainfall. That it was when we'd get these drier air masses and a northwest flow, continental flow, that we really see the high afternoon temperatures. And so we'd see less rainfall during those times also. But that hasn't really held true. Over the past few years have been some of the warmest on record across the state, but also we've seen above normal rainfall at the same time, even up into Alabama and Georgia. So there is a loose correlation between more or extreme heat events and less rainfall, but it doesn't necessarily hold true, and certainly not in recent years.
Interesting. So final question, and I'm hoping maybe this might leave us on a slightly more hopeful note, though maybe not. Can you speak a little bit to the most recent IPCC 6th assessment report and sort of what it said generally about, if we collectively take drastic action to reduce emissions, and what that could mean in the next several decades in terms of the potential to stabilize temperature?
Yeah, getting into these IPCC reports is getting a little out of my area. I more concentrate on statewide and regional climate, but the big take-home message is, we had set these goals of 1.5-degree warming or 2-degree warming, where 1.5-degree warming looks almost unreachable right now. But that's not a reason to lose hope. It's whatever we can do to reduce greenhouse gas emissions and move closer and closer to net zero. The sooner we can do it and the more we can do it as a global society, the less drastic impacts we'll see from climate change as we go forward. So in my mind, there's not a particular set threshold or cliff or something that we got to look out for. It's whatever we can do as quickly as we can do it will only help protect us from the more extreme impacts of climate change.
Absolutely. Absolutely. Well, thank you so much, David. This was incredibly informative and really appreciate it. So next, I'd like to turn it over to Dr. Chris Wagio, also at FSU, assistant professor within the Department of Geography. Chris is also the co-author of the CDC's Building Resilience Against Climate Effects, or BRACE framework, which supports health officials in developing strategies to help communities prepare for health effects of climate change. And he's going to share a little bit more about this. So Chris, thanks so much for being here and for sharing your expertise with us today.
Thanks, Lauren. Thanks, Jane, and thanks others for the organizing committee for the invite. We'll be talking about impacts of extreme heat in the region. Next slide, please. And the one after that, please. So there's potentially a lot that we can cover here. I will certainly try to keep it moving, but if there are some key topics that I brush over, would love to hear your questions and thoughts. So I'm just going to start off with a broad view of extreme heat in Florida. And a lot of that work was conducted by the research team here at Florida State University. David Zerden is part of that, our Florida BRACE team, as well as Ji-Hoon Jung, who also worked with David. So big hat tip or recognition to him. We'll talk just very briefly about the Florida and perhaps future other building resilience against climate effects programs. And I'll end with sort of a high-level overview of insights into vulnerability mapping, particularly for extreme heat. Next slide, please. So who is at risk? So we like to say that everyone is at risk, but some people are at more risk. And that's sort of a key message, just because I think it's easy to think that only certain subgroups or populations really face heat risks, but really that's not quite true. So the ones that face higher risks are older adults and people with pre-existing health conditions, particularly pre-existing health conditions that are respiratory or cardiovascular or related to your kidney functioning, renal diseases. Older adults just physiologically are less able to sense when they're thirsty, to rehydrate as well. Depending on the chronic disease, it also impacts the ability to sweat and heat loss. On the other end of the spectrum, infants and children are also at risk, but for different reasons. They may have trouble communicating, they have smaller body sizes, so they can heat up more rapidly. I should note this is a CDC slide, which I've modified without permission, and I've added pregnant or expectant mothers as well, which we know are an important risk group too, which exposure to extreme heat, particularly heat waves, but also perhaps prolonged and hot and humid temperatures can also increase the risk of adverse birth outcomes. Similarly, an area where I've sort of altered this, the low income and the unhoused. So lower income houses, I think Miami-Dade has done some great work on trying to calculate the proportion of income spent on energy. There's been some previous studies, for example, an AARP study in 2010 that showed that the poorest households, those receiving energy assistance, spend about 16% of their income on electricity. And that's not hard for us to wrap our heads around in sort of South Florida, where AC is running pretty constantly. And that's going to be comparable to the cost of food or transportation. So that's a pretty big deal. Athletes and outdoor workers, other people who are outside, intuitively also face higher heat risks due to higher heat exposures, and they're generating heat from their activities. They may also wear personal protective equipment and other things for safety that also increase their heat stress. So in summary, some of these categories aren't too different than what we were maybe used to thinking about for COVID. Next slide, please. So where are some of the areas that have our highest extreme heat disease burdens? You'll see in this talk, I'm going to try to be advocating for looking at heat-related health outcomes as sort of one of these metrics, but each health outcomes tells a little bit of a different story, and that's important to keep in mind. So if we look just at emergency department visits, we actually see Southwest Florida, it's not pictured here, sorry, Lake Okeechobee, Mariana, some parts of the panhandle of Florida actually have the highest emergency department rates, but that's again, not the complete story. That's largely reflecting those people who are outdoors, are outdoor athletes and workers. Then the older adults is largely going to be reflected in these cardiovascular and other older adult conditions, hospitalizations, and emergency departments visits. So here, this is an odds ratio, but essentially a number greater than 1 implies greater heat risk, and 1 below 1 means that you're protective or you have below average risk. But essentially, as we can see, sort of the southwest portion of our domain, largely due to having older populations. Next slide. Delves into this in a little bit more detail here. Interestingly, just across the state, if we're looking at what are the heat risks at a county at a very aggregate level, right? This is not really looking at sort of neighborhood level disparities quite yet. But it is somewhat consistent with what we see across the nation or across the globe, that being under 5 years old increases your emergency department visits for heat. If you're living in a hot and humid climate, being an older adult, particularly those who may have existing health conditions or need more support from social services, having a notably greater than 1 odds ratio. Females might have lower rates of cardiovascular hospitalizations. That's actually just consistent with they actually tend to develop, they have risk factor. They're less likely to develop cardiovascular disease in general, since they, we see that there are some other key groups that pop up here as well. I'll just jump to the last line there, but children under 18 living in 1-parent households, but oftentimes, right, single mother head of households, which globally are one of our most important heat risk groups. Some of that actually is true for Florida as well. Next slide. So I'm going to shift a bit from, I'm just going through each of these groups. So now I'm going to shift a bit to those outdoor workers. So this is a somewhat wonky term, but wet bulb globe temperature. It's essentially just temperature, humidity, sunlight, minus the cooling effect of wind. But this is going to be an important concept for an area like Florida or the Southeast, where we're not just concerned with the occasional once or twice a summer heat wave event where heat levels are dangerous. It's almost consistently in July or August, particularly in the afternoon, you're going to face some dangerous heat levels. So what can we do then to manage it? So this slide here is actually just from the Deepwater Horizon oil spill, and they tracked pretty well the frequency of injuries, not just heat-related illness, but also injuries, since as the temperature and heat exposure rises, you're more likely to make mistakes. You're going to have to file workers' compensation claims. There's a variety of different things. In addition, your cognition goes down, in addition to just heat-related illness. So at least what we see here on the bottom on that x-axis is essentially we see this sort of exponential relationship. But essentially as heat exposure starts to go up, your frequencies of illnesses and injuries and so on also increase. And that's actually pretty true across the globe. So we actually have a somewhat fundamental limitation to the heat exposures that we can engage in activities in. Next slide, please, or next click. Just as important is that productivity actually decreases 30% for each degree increase of wet bulb globe temperature. Right, so that doesn't directly map on quite 1-to-1 with a 1 or 2 degrees Celsius rise, but I think it makes it a little bit more tangible to say that for people to understand that 1 degree Celsius rise also has a huge effect on labor productivity for our outdoor workers. Next slide. So what do we know just in general about outdoor workers? We know the class of the worker is important. If you're on a temporary visa, you're more likely to be exploited. You might have a more precarious situation. Gender and job roles in many of these jobs overlap. There's certain men are more likely to engage in certain types of agricultural work versus women. It's not to essentialize that or say that it has to be that way, but that tends to be what we see. Compensation. We know that essentially those who are paid by the piece, how much a fruit or vegetable or produce product that you pick, also have higher rates of heat-related illness. And then, which I'll just mention just briefly with another slide, perhaps citizenship status too. We're starting to find some evidence that people without Social Security numbers face higher heat-related illness risks. Next slide. Just given the composition of who's attending this, I just wanted to touch on very briefly, this was a small study we just did in the city of Tallahassee with our municipal workers, but since many of you are city managers, this is essentially a table summarizing the delta or the difference between heat exposures faced by actual workers in the field and the airport. In this case, we know in Tallahassee, we know our airport's probably cooler. In some of your cities, that might also be the case. Some key points here: public works in general spent almost all their time outdoors. And we also asked about time in an air-conditioned vehicle or an air-conditioned substation, followed by sort of public recs, solid waste, and underground utilities. Spend about 2/3 of their time outdoors as well. And then fleet may spend a decent amount of their time indoors, but in unair-conditioned spaces due to the need for ventilation to move fumes out of the way. So happy to share all these studies thus far. Next slide. As I mentioned, people without a social security number, in this case here, those with and without a social security number generally face the same heat illness risks in terms of severe heat-related illness in the state. However, there's a couple of key differences, one being dehydration emergency department visits, where we find that those without a social security number have higher illness risks, and as well as renal or kidney disease hospitalizations. Not shown. Next slide. So just the direct and indirect health costs add up to about 667 million. That's for the Twin Cities, Minneapolis and St. Paul, which I know is not South Florida, but that's about the city where we have at least pretty good estimates, and at least population numbers wise, it gives you at least a ballpark to start at. Not exact, but applicable, but a pretty big deal. Next slide. So I'll just talk very, very briefly about the Building Resilience Against Climate Effects framework. It's next slide. It's a 5-step framework. And it's really trying to address this key issue through a couple of national surveys, one which was a little preliminary, and the second one, which is cited below, which is more systematic. But essentially, does your health department have ample expertise to assess public health impacts associated with climate change? And by and large, most health departments would not agree with that. And that's not particularly surprising, given historically a lot of the training emphasis in environmental health programs across the nation haven't included climate change. That's starting to change relatively rapidly now, but it's still a major structural barrier. Next slide. So the 5 steps of the BRACE framework, one is pretty much, step 1 is pretty much what David discussed in his previous talk, what's going to change and how is that going to impact health. 2, maybe extending that a bit further, including those climate change projections. And then steps 3 through 5 really switch from sort of the science of it to the science of understanding it to the science of implementation. But essentially, what can we do? And that's, I think for many people in the audience, that's really what you're most concerned about. What can we do now? What works, what doesn't work, how much does it cost? Is that sustainable? And then together, those interventions are supposed to provide a climate health adaptation plan. And then, of course, we'd like to evaluate all 5 of the steps along the way in a sort of an iterative process. Next slide. This is an example of one of our sort of local champions of climate and health. This is Dr. Carol Jeffers from Sarasota, County Health Department. She held a series of workshops with representatives from at-risk groups, whether those are the unhoused, people from assisted living and nursing homes, a variety of other sectors you would consider at risk for, in this case, a dual disaster, if you will, of hurricanes and evacuations and a side of extreme heat. But essentially, she asked these representatives to come up with solutions. And instead of being sort of top down and saying, this is what the science says, you tell us what you think your clients would need. We can try to find that information. If it isn't there, we need to collect it and answer that question. And then we're going to directly use your input to update our comprehensive emergency management plan, which informs evacuation activities and responses across the county. So that's an example of sort of how it's sort of all connected. One note before I move on from BRACE, Florida BRACE at FSU, with the support of the Department of Health, this currently is not funded. Similarly, there's Miami-Dade Building Resilience Against Climate Effects program that's under consideration. We hope it's possible that those two can both be funded going forward, and I applaud the leadership of Miami-Dade for applying for that. Next slide. So I'm just going to move briefly with the rest of the time I have to vulnerability mapping. And sort of go from there. Vulnerability mapping in 2006, the CDC and EPA invited us to sort of the first environmental heat and vulnerability mapping conference, and we'll provide sort of a broad overview of literature. Things are still advancing from there, but I'll just provide some of the common ways you can approach this. And I'm not going to say one has to approach it one way versus the other. At this point, I think as long as you're thinking about extreme heat and trying to do something about it, you're on a good track. Next slide. Okay, so extreme heat. I mean, many of the other panelists will talk about this, right? It's responsible for at least 12,000 excess deaths in the United States per year, making it the #1 weather-related and human health issue. Extreme heat, on the individual level, we know a lot about how to treat. If you're thinking of a medical doctor, if you have someone who has his body is overheating, you need to cool them down and rehydrate them. Pretty straightforward. On a societal level, that's where things get tricky. Right? We have the unhoused, we have people who are living alone, we have areas with differential trust of authorities and crime, we have historical zoning and racism. And then what do you do about that? Our tools are a lot less clear or direct. Maybe we have some broad public messaging or public broadcasting, so we can set up cooling shelters or refuges. Maybe we can subsidize some people's energy bills or disseminate air conditioning. But this is a much trickier problem. We have to know where everyone is, and they want to have to consent to having some sort of assistance. Next slide. So big picture, vulnerability mapping, and in heat, what can you do to understand heat-related illness in your area? I think there's a few approaches. I'll sort of step through these. The first one is just mapping out rates of heat-related illness, and that makes a lot of sense, and that could be an intuitive, good place to start for you. With the next click is what we would call overlay analysis, but essentially we have a certain number of risk factors. We call them either societal determinants of health or essentially things that we know make people more at risk, either sensitive or less likely to have the financial means or other social means to be able to adapt to extreme heat. So you could overlay just those risk factors in your area, and there's a lot of places that do that, and that's okay too. You may also include exposure in there, like a satellite image of the urban heat island or something along those lines. And at the next click, perhaps another way of building on that is actually to relate all three of them together. So not just consider the health outcome independently, our risk factors independently, but really try to figure out how our risk factors, meaning characteristics of where you live, whether you have health insurance, your economic status, some of the things we talked about already, influence if you have higher disease rates systematically in the jurisdiction you're most concerned about. Next slide. So again, stepping through these heat-related illness, I bring this up for a couple reasons. This was classified extreme heat deaths. We know these are vastly undercounted. This is just in the Houston area that we have for Harris County. The first thing I just wanted to point out here is that you can see this is, I believe I did this at census blocks, which are relatively small neighborhood units, about 1,000 people, 1,400 people. But I point this out to see kind of how patchy this is. So we know that even there's some relationships, some neighboring areas tend to be next to other neighboring areas with high rates, but that's not always true. And even obviously within some of these areas, we know that there's going to be some high and low areas of heat risk. Next slide. So moving on to that right-hand side of the equation, if we can look at the heat-related illness, but we can also look at some of these predetermined or known risk factors from the literature, whether it's vulnerability, social isolation, or resilience factors. lack of air conditioning, or pre-existing health conditions. So with another click, please. This is sort of an overlay, and this is Colleen Reed's work, which is one of the first ones out there. And I just pointed out here, this is a pretty decent map too, right? We get to see areas of high and risk zones of heat-related of risk, but right, compared to the heat-related illness map, it's much smoother. It's not as patchy. We're not really getting at those adjacent neighborhood differences. That's okay. That's still at least trying to start to do something actionable about this problem. And then someone can build from there. Next slide, please. And then I mentioned there's sort of a third approach where we are using our locations of our health heat-related illnesses, however we define those, to determine the relative importance of our socio-demographic or risk factors. And this is just a study we did in 2012 around the Phoenix area, Maricopa County, which some of your other speakers will talk about. Here, this is sort of like our observed counts of heat-related 911 calls, and on the other side are those fitted calls, the ones that we can statistically find associations with. Well, we're not doing perfect there either, to be honest, right? Like there's areas here where we know they have some gaps. We're catching some of it here, but not all of it. The benefit is on the next slide. We can provide some insight into what's going on. So essentially here, again, an odds ratio greater than 1 means you have a higher heat-related illness risk. Those lower than 1 can be arguably called protective or prevents heat-related illness associated with lower heat-related illness. So in Phoenix, we found that having higher nighttime surface temperatures, as implied by the overheat island, higher amounts of impervious surfaceness, increased your risk of heat-related illness, at least at the neighborhood level. Next click. And these are all the socio-demographic variables here. I won't belabor them too long, but many of these are consistent with what we find: renting, those whose English is not their primary language, Hispanic, which I think actually means something different in South Florida, higher proportion of people living alone, Black households having higher risks, while those having a higher proportion of Asian American households, and interestingly, people aged over the 65 have lower risks. And I actually wouldn't be surprised if we saw something like this in South Florida, where essentially our retirees are not necessarily the key older adults who are living alone, who are socially isolated on living on a fixed income. Maybe they are richer retirees who have moved to the area and are doing okay. Next click. Okay, so what are some just general thoughts? Everyone is at risk for extreme heat. When we show these vulnerability maps, there's places like San Francisco that have provided guidance that we don't necessarily want to classify or state in areas at low risk then, or no risk implied for extreme heat related illness, because that's not the case. We know that it can happen across your domain. It'll just be relatively lower or not as high. In 2006, when we had this workshop, 2006, Chris would have been delighted that actually people were actually using these. At the time, I wasn't super confident that anyone would ever use them, but they are guiding decision making across jurisdictions. New York City, which Kizzy will talk about, San Francisco. There are places that are prioritizing heat-related interventions based on maps or more sophisticated versions of these maps. I know I went through a lot relatively quickly, so this guide here that we wrote with the CDC, it provides a little bit more information about some of those steps, and I'm happy to talk further. I suspect I'm about at time, so I'll skip the next 2 slides and take the balance for questions.
Great, thank you so much, Chris. Really appreciate all of that information. So we do have several questions for you. So first of all, can you give us a sense of how robust our ability to measure heat-related illness or injuries or hospitalizations are here in Florida? And I guess a correlated question is, I mean, do you have a sense of the degree to which our health departments or hospitals are collecting this data related to heat stress?
Yeah, great question, Lauren and audience. But essentially, if I like to make an analogy, I'd say COVID, just to make, because everyone, it's on your mind and you probably don't want to think about it again. But let's say our COVID deaths we maybe only count 1 out of 3 COVID deaths. For extreme heat, it's probably 1 out of 10. So, and that's probably true for deaths. emergency department visits, hospitalizations, and just actually feeling malaise, subclinical malaise, like you may not feel like you can go to work that day, but maybe you're not sick enough to go to the doctor.
And how important is it to kind of do better in collecting this data to improving our ability to respond?
Yeah, great question. So I mean, at the risk of being an academic who always says, we always need more, we need more, more
Yeah.
research.
Yeah.
But I think it is true. Like, how can we evaluate if our programs are effective if we don't have a true number of how many people are actually getting sick and ill, so we can sort of improve upon it? And I think why it is important, and other panelists will speak to this, but a lot of heat-related illness is preventable. I won't know you say that it is all, but I think a good chunk of it is. And knowing what is preventable and being able to do that with relatively potentially straightforward, for some groups, interventions is a worthwhile investment.
So I'm not sure that you might not be able to speak to this level of detail, but the question came through and I do want to transmit it. So regarding student performance, some national studies have found that there are significant effects associated with temperature. Do you have a sense, Chris, of how extreme heat here in Florida has affected student performance?
Yeah, great question. Just generally, I won't be able to speak to Florida specifically, but I would extrapolate from at least one of the study's results. A lot of those are in places that don't have air conditioning.
Okay.
So sort of particularly at the starting or the end of the school year, or where some of these places had lower rates. I think South Florida, but I mean, that being said, now that I think about it, we actually just looked at air conditioning prevalence across the state, and the Florida Keys has 80%. It's not as high as you would have guessed. Okay, maybe some people in Keys would have guessed that, but but I think it could still be an issue then for some people in the Keys. That's a good point. But generally places with lower air conditioning rates, so maybe more north central Florida, aside from the Keys.
So you spoke a little bit about BRACE, and it's not funded right now, correct?
Correct.
So how does BRACE get funded? And if it were funded, how would it support local governments and communities around the state?
Yeah, great question. So BRACE has been running for about 10 years. It was the only new appropriation under the Obama administration for climate change, not just climate change and health, just climate change, period. It could be transformative. It essentially would provide funding for Florida, and then there was a separate proposal by Miami-Dade, but also for them to also essentially implement two relatively big interventions, meaning let's do something about our climate and health related problems and evaluate it, see how they work for 5 years. So sustained funding, try to build that infrastructure, build that capacity, that knowledge in those institutions. BRACE and the CDC itself has historically worked through a sort of a hierarchical model through counties. So historically, counties have been sort of the lead actor on that space, but I think everyone recognizes a lot of the interventions aren't, not only do they not only fall under the county, but they also fall in other sectors, whether it's a city or a private private sector or civil society groups. So it could be really helpful, and the state needs it.
Yes, absolutely. Well, we will be pushing for that for sure. Well, with that, Chris, I'm going to close it out, and we're going to turn over to our next speaker. But thank you again. We're so grateful for your time. So now we're going to hear from Jane Gilbert, who was appointed a few months ago in a first of its kind position, both in the U.S. and globally, as Chief Heat Officer of Miami-Dade County by Mayor Levine Cava. Jane has really hit the ground running in this new role and has already has enormous amount of expertise to share with us regarding community planning for extreme heat. So Jane, really thank you so much for all your support, not only in just sharing your knowledge today, but in supporting the planning of this workshop. So I'm going to turn it over to you now. Thank you.
Great. Thank you, Lauren, and thank you, David and Chris. Really outstanding and informative presentations, which will help me move quicker in the beginning of mine. So next. So I'm going to quickly go through just the heat risks in Southeast Florida, more to highlight some different resources, which I will at the end of this presentation put all of them in the chat so that people have access to the links. Really talk about why a chief heat officer, to Chris's earlier point about the importance, or maybe it was David's, of governance across departments and across sectors to address heat. That's really the reason behind designating myself as the chief heat officer. And then how we're addressing heat risks in this diverse community, which I hope will have a lot of crossover to all our Southeast Florida communities that are on the call today. Next. Keep going. So this is in the Southeast Florida Climate Change Compact climate indicators resource page. There's a whole area on temperature that goes to David's point of having 2 degrees Fahrenheit average increase historically. And this is projected, to Lauren's point earlier, to get to 4 to 10 degrees by the end of the century, given current greenhouse gas emission trends. Go ahead. Next. As are some of the Union of Concerned Scientists predictions, or actually this is taken from the NOAA climate assessment, but by mid-century, we could have close to 3 months a year that gets at 105, in heat index of 105 or more. Sorry for my dogs. And that is where a level at which it is dangerous for everyone to be exposed, not just certain more sensitive populations, but everyone to exposed for any significant time. Next. And we have a compounding risk here of an extended and widespread power outage. Could be from hurricanes, could be from something else. But as everyone saw here in Hurricane Irma, we had a tragic loss in a nursing home in Hollywood due to power outages. Since then, the state and our local governments have been very good about enforcing new policies to require all assisted living in nursing homes to have the backup power and fuel to keep an area cool for at least 4 days. However, we know that we have many more populations that are at risk. And I just want to personalize this because it is hitting all populations. My father-in-law passed away about 5 years ago of a heart attack, but he had lost power in his house and it was August, for a few days prior to that. And I'm convinced that it was accelerated to that heat. I have a daughter's jump rope coach who was only 32 and passed away this summer in New Orleans, and having been exposed to heat for a long time. So this is really hitting us all. Next. The biggest risk, I believe, is within people's homes. We don't have good data on this, but we believe that most of the heat-related illnesses happen in housing because they can't afford, they have inadequate cooling, or they can't afford the cooling. And just one resource is the CDC environmental public health tracker. I'll also put that in the chat. We had just documented over 6,800 heat-related hospitalizations in the last year throughout the state. So it's a serious issue. Keep going. The other, keep going. The other area of highest risk are our outdoor workers. In Miami-Dade County alone, we have over 300,000 We have the highest number in the state, and my guess in South Florida, we probably have well over a third of the statewide outdoor workers. These are people that often can't get out of shade, don't have adequate access to potable water and breaks during this time. The Union of Concerned Scientists did a very robust report, Too Hot to Work, that includes some of this state and county level data that you can use. And the Arshtrock Resilience Center also did a social and economic analysis for the country. And then they are going to be doing one specific to Miami-Dade County, which once that's out, we certainly will share. Next. The other area which David highlighted so well is our urban development patterns. So climate change plus urban development patterns have increased our heat health related risks here in South Florida. This is from our updated urban tree canopy on the left. Is our land surface temperature and the variation, which can be up to 17 degrees Fahrenheit, different land surface temperature depending on where you are in the county. The one on the right is the net change we've had since 2016. So not a huge amount of change, but basically we have had no net, through our urban tree canopy, we've had maintained essentially the same urban tree canopy and had slight changes, losses from hurricanes and development patterns and gains from both county, municipal, and private sector planting efforts. Next. And this is by our municipalities within Miami-Dade County, the average percent. So we have areas like Hialeah and Opelika, Hialeah Gardens, that have less than 10% urban tree canopy. And then areas like Coral Gables and Pinecrest that have, 30 to 47% tree canopy. That's really where we want to be, countywide or region-wide. And that has a marked difference in the feels-like temperatures of those areas. Next. And they align very well, or unfortunately, align very much with our low-income areas. The lowest tree canopy is also, this is tree canopy by census block and or census tract, and our household income. The darker areas being lower income. Higher income on the left and higher tree canopy on the right, and the white areas being more lower income and lower tree canopy. Next. And if you're not able to do that full sort of tree canopy assessment, that was done by University of Florida and Florida International University. The American Forests has a tree equity score that you can go to and put in your municipality or county and get the full score and further data. Next. So why Chief Heat Officer? Go ahead. So as Lauren said in the outset, South Florida is known internationally for its risks to sea level rise and increasing flood risks related to climate change. And heat has been something that's been growing both locally and nationally in terms of awareness. Locally, I, as the Chief Resilience Officer for the City of Miami, when we were doing outreach, neighborhood level outreach for our climate adaptation strategy, and asked people their top concerns around climate change, heat came up a lot. It wasn't long after Hurricane Irma, so there's a lot of concerns around power outages, and heat came up a lot at that time. But then last year, Catalyst Miami led a group which is a community-based organization here, a group of other community-based organizations to do focus groups and surveys in our more socioeconomically vulnerable communities about what their top concerns were with climate change. And heat and this geographic displacement were the top two concerns. And they've started to work on a policy agenda. On the international front, our partnership with Adrienne Arsh Rockefeller Foundation had been kicked off in 2019. And last year in 2020, they formed an extreme heat resilience alliance of cities internationally, experts internationally, to look at the impacts of extreme heat and what to do about it. And it was really out of a conversation between Adrienne Arsh and Mayor Daniela Levine Cava that the idea of appointing a chief heat officer, someone who would work across departments and sectors to develop a more unified approach to mitigating and adapting to extreme heat was born, and it was announced in late April of this year. And next slide. The idea is that actually my position is contracted with funding from both Miami-Dade County and the Arsh Foundation through the Miami Foundation, who has been the organizing partner host of the Resilient 305 partnership that came out of our 100 Resilient Cities strategy development. So it will be developed and managed under this pivot team of the Miami Foundation, the City of Miami, Miami Beach, and Miami-Dade County, and it will be a plan like the Resilient 305 strategy that includes actions that will be led not only by these four entities, but by other nonprofit, public sector, and private sector partners. Next. A lot of it, since it was an idea and appointment by Mayor Daniela Levine Cava, she takes this issue very seriously, just spoke about it at COP26 in Glasgow last week. It's been added as a part of the Office of Resilience portfolio between mitigation, sea level rise, communication, Biscayne Bay. Heat is been added, and they are putting their staff fully behind these efforts as well. So the strategy will definitely have a lot of leadership actions from the county itself. Next. And it will be connected and integrated not only with the Resilient 305 strategy, but Miami-Dade County sea level rise strategy and their recently released climate action strategy. I've been very involved, particularly with the climate action strategy, and making sure that the thinking around heat mitigation and heat adaptation, but heat mitigation in particular, is integrated into that strategy. Next. And collaboration is key through this compact, through the Resilient 305. We've had a number of collaborations with the Health Foundation, historically between the Resilient 305 strategy and our COVID response. And there now we're in discussion with them being involved with the with the heat mitigation. And then internationally, not only with the Arsh Resilience Center, but with our Resilient Cities Network and the Global Cool Cities Alliance, the former director of which is Kurt Schickman, you'll hear from later today. Next. Our strategy will be developed by an interagency and diverse task force, 15 members. We've appointed 13 and are currently finalizing. Today's the deadline, final deadline for community members to apply to be part of this task force. We certainly want to make sure that the community is well represented. There'll be 6 public meetings that will engage the public on different areas of heat, health, mitigation, and adaptation, from trees and urban planning to housing to outdoor workers to public education and outreach to further data and research needs, et cetera. Next. And that'll come out in May of next year. We'll be kicking off our first meeting this month. So how are we addressing heat risks in this diverse community. Next. So we also just released a climate and heat health toolkit. This was developed with the Office of Resilience at the county and USDN funded intern Kelly Solaruli over the summer, where we interviewed both internal department lead stakeholders, other municipal lead stakeholders, as well as from the healthcare sector, the community-based organizations, and our university partners. And really, this toolkit, I think, can be useful and is accessible on the Miami Foundation Extreme Heat website. And I will, again, make sure you all have links to that, as well as the information on the task force. But similar to other climate action strategies, climate adaptation strategies, we have a high priority on being equitable, not adding to greenhouse gas emissions while we're coming up with our adaptation interventions. So if, for instance, if we're talking about cooling in housing, we want to make sure the emphasis is on improving the energy efficiency of that housing stock overall, and the AC unit or AC, the cooling equipment itself has to be highly efficient so that we're reducing the utility burden and the impact on greenhouse gas emissions at the same time. Want to make us safer. These need to be flexible. We have changing conditions and integrate nature as much as possible. And it needs to be aligned with all our county and other plans. And I'll talk more about that, but transportation plans, certainly the climate action and sea level rise strategies, the comprehensive plan, parks and open space, our street tree master plan, our resilient 305, our local mitigation strategies, many other plans that it needs to be integrated with. Next. So the three main areas is, and I will wrap it up soon, is environment, infrastructure, and community engagement. Next. So this summer, we launched a social media strategy with the Armstrong Resilience Center and also encouraged other cities to join us. I think we had about 14 other cities in the US that joined us on that campaign. Next. We also partnered with Armstrong on their resilience pod to inform people of all climate risks and adaptation strategies. Next. And did physical posters in our public spaces in Haitian Creole and Spanish. Next. In our parks and libraries. Next. Next. We also partnered with the National Weather Service on upping their communications with the daily hazard reports around heat risks. So that benefited all of Southeast Florida with that messaging. Next. And worked with our parks on a lesson plan. We had 30 summer camp parks for students to learn more about and recognize when they feel heat stress and what to do about it, and then also gathered information about where and when they're experiencing heat stress, whether it's at home or at camp, and what strategies they're doing. It was very helpful. Popsicles and splash parks are very popular. Next. Our evacuation shelters, while they all have some form of backup power, most of them are not all of them have enough backup power to keep the shelter itself cool in the event of a hurricane. So that's one of our top priorities, is to make sure that we have that capacity. Next. And ideally, again, to make that with solar power and battery backup. Next. We're also looking to enhance and expand our citizen emergency response teams and make sure they have the knowledge, equipment, tools, and ongoing communication about what they can do to check on their neighbors and keep them cool in the event of both high heat times and power outage, or those neighbors that might not be using their AC or have access to AC. Next. That's our partnership with the RSTROC. Keep going. Keep going. Our cooling shelters tend to be our parks and libraries, and they're currently also do not have the backup power in the event of a widespread power outage. So those are things that we are working on with next, the RSTROC Resilience Centers. Next, please. Grant with the state of Florida. They got a planning grant through Rebuild Florida to evaluate and develop a recommended network of resilience hubs, which will be essentially turning some of these previous points of distribution during an emergency, cooling centers during heat, into year-round programmed activities. These are generally either park community centers or libraries or other community-based facilities that will have ongoing programming about adaptation and preparation, as well as have the capacity to be a place people can walk to, cool off, charge their phone, and access services in the event of some sort of disaster. And they'll be networked with our CERT teams to help support those efforts. Next. Heat is not currently in the Miami-Dade County local mitigation strategy. So that's one of the things we're also working on, is to make sure that extreme heat risks are included so they can be eligible for mitigation project applications. Next. Next. So with the outdoor workers, we've been partnering next with the a farm worker group called We Count on looking at the potential for a policy within Miami-Dade County for outdoor workers but at the same time, the Biden administration came out with their commitment to work with OSHA on a ruling to require basically the access to potable water breaks and shade during high heat times. So this is something that we're going to be doing more outreach and we'll be doing more with both the employers as well as workers to see how we can do more to address this. Thank you. You can just flip through to the end. We'll go. This is just some various tree planting. We have a lot to do on tree planting. We've set a goal of 30% by 2030. That 30% goal was set and not realized over 10 years ago. So we have to figure out how we do things differently to get to that goal. But again, I don't want people to think that tree planting is the answer to heat mitigation and adaptation. It is an important piece, but really working on our housing stock and with our outdoor workers will do the most to address heat risk. With that, I'll open it up for questions. Thanks.
Fantastic, Jane. Thank you. Like I said, you have already certainly covered a lot of ground in your short time as the CHO, I guess, if we're going to use the acronym. That was fantastic. Really appreciate all of that. Somebody shared, just thanks, and I want to echo that for sharing your own personal stories of tragedy and loss, and I'm so sorry for them. Related to heat and how that's impacted you personally. Certainly these types of stories, I think, give names and identities to kind of the statistics that we're reading about. And a related, kind of question that actually was posed earlier to David that we didn't have a chance to get to, but I think it's related, is about how a lot of folks in the lay public or the general public hear a 1.1 degrees Celsius and they think that it's trivial. So how do we do better about communicating and telling these stories? And you're out there having to communicate about heat in a very hot place. You know, how are you talking about this in a way that people can really understand it and understand it's not just that we live in a subtropical climate, but really getting at the true risks that our community is facing?
So I think one of the things that I've picked up over time is how climate change is a risk multiplier, particularly for our most vulnerable populations, right? We've always had a hot climate, yes. And it's always been harder for our most socioeconomically vulnerable populations. But we have higher inequities, and we have higher temperatures and higher humidity. And so it's more expensive, it's more common that those populations are going to be exposed. And we have, just with construction is our biggest number of outdoor workers. And with all the growth that we've had here, we've had a massive amount of increase in outdoor workers. So that's greater exposure. So I just speak to some of those issues and some of the personal stories that I've heard, even in gathering these community member applications of guys who are roofers and their buddies passing out or falling off a ladder and having a permanent disability and they can't work again. Of people who can't afford the AC, and the kid that says their grandma, went to the hospital in his response on the camp application. It's just those are some of the stories that I think do start to resonate with people, because everyone can start, if you start to think about it, you will identify whether it's your kid on a football team or your abuelita, or your uncle who works as an electrical engineer on a construction site, you will find how it hits your community.
It hits your home, absolutely. So, you shared the toolkit. It's a fantastic resource. We shared the link in the chat with all of the attendees of this webinar. And I know that you've done a lot of kind of looking across our region in the last several months. Somebody asked, are municipalities here in Southeast Florida advancing, heat protection policies? Can you talk about, you talked about tree canopy, and certainly we know folks are doing that. I mean, how much of this work do you get the sense is already happening and we're just not necessarily identifying it as a heat adaptation or heat mitigation strategy? Versus how much more do you think our local governments in Southeast Florida really need to do that's very focused?
So I'll highlight a compact initiative on energy efficiency in homes. I think that we need to increase, and many people are, with federal funding, increasing their weatherization programs, but making them more user-friendly, more accessible, and more flexible to do not only the weatherization retrofits, but energy efficiency and AC, improved AC installments, as well as climate health in those both single family as well as multifamily retrofits. To me, what keeps me up at night is our housing stock being vulnerable, not only to the ongoing chronic issues of extreme heat, but in the event of a major hurricane. And so I would start with that, is that any of your housing retrofit, housing redevelopment projects, to make sure that they're efficient and weatherized and resilient, and with, to the extent possible, with backup power. Secondly, I think we are all working on updated streetscape plans with more canopy, more natives, more shade trees. We just need to accelerate that work, and we need to make sure that we get down into our public works to make sure their practices are reflecting those guidelines and goals. And that's something that we're working on internally in the county. So I know we're not alone in that challenge.
Right. Well, and certainly incorporating, this into local hazard mitigation and being able to access those dollars is going to be hugely helpful towards trying to advance the work more quickly and finding some funding to do that. On a related note, are you working with Florida DEM to incorporate heat into the rewrite of the state mitigation strategy that's currently underway? And what are some state policy changes that would help support your work or potentially pose barriers to the work that you're trying to get done?
So I haven't approached the state DEM yet, but that's a good point. And now that we're going to be partnering with RSTROC on this Resilience Hub plan, I think that's a perfect opportunity for us to do that together with them to look at heat in their plan. So I take that as a charge more than I can actually answer.
That's good. That was a really great point brought forward by Janet Bowman from the Nature Conservancy. I'm sure she would love to brainstorm with you. You touched on this a little bit, Jane, and this will be the last one, and then we'll close out and we'll take a quick break before we move into the next piece of the program. But because of the reality of being sort of Hurricane Alley here in Southeast Florida, we have a great history here of really strong emergency management folks. So can you talk a little bit more about your kind of vision of partnering more with those teams in terms of really thinking about the heat work that you're doing and kind of expanding the purview beyond the focus around, emergency response to hurricanes?
Great. Well, I don't know if people heard, but the mayor announced, Mayor Daniela Levine Cava, that this next May, we will begin a heat season of a communications outreach that will be on the level of hurricane preparedness outreach that we do across Miami-Dade County. And that's something we will be absolutely doing in partnership with our Office of Emergency Management. It's different because, like we talked about here in South Florida, we have some chronic issues as well as episodic issues to address. And so those preparation tips will be addressing both, and we'll be looking to do a deeper outreach. That's where the citizen emergency response team enhancement and expansion is going to be really critical. Really, we don't have good data on who's suffering in terms of inadequate, what we call AC insecurity, whether there's inadequate actual equipment and housing or its lack of ability to afford it. We don't have good data on that, but if we could get a ground game that helps us understand where those issues are, we may be able to be better about addressing some of those needs. So that we will be doing in partnership with them, as well as integrating heat in the local mitigation strategy and working for funding to get the backup power at both the evacuation shelters and the cooling centers / resilience hubs.
Well, fantastic, Jane. I know I am personally just thrilled about your appointment and this role, and I think others across the region feel the same way, and look forward to continuing to learn from the great work you're going to be doing in collaboration with many others, and through Mayor Levine Cava's really strong support for this effort. So thank you so much again for all of this information and for your help in designing today's workshop. So we are going to now, we're running just a few minutes behind, so we're going to take a break and we'll come back here at 10:55 and get started again. So just a quick bio break. Thank you all for being here. All right, everyone. Well, welcome back. With that, let's dive back in. The second half of our program, we're going to be talking and really digging into solutions. Up next, we're going to learn more about urban cooling strategies from Kurt Schickman, who recently transitioned to the Adrian Arsh Rockefeller Foundation Resilience Center as the Director of Extreme Heat Initiatives. Prior to that, Kurt led the Global Cool Cities Alliance, a nonprofit organization working with over 70 cities to implement passive cooling solutions and policies. And then after Kurt's presentation, we're going to hear from Dr. Larry Cockstein, bioclimatologist and professor within the Department of Public Health Science at the University of Miami. As a double alum, I'm glad to have some UN representation here today, since we've had two folks from FSU. So great to have you here, Dr. Cockstein. Larry's also the co-founder of the Los Angeles Urban Cooling Collaborative, and he's going to share a case study from LA's collaborative on the benefit of urban tree cover and solar reflectivity for public health. So after we hear from both Kurt and Larry, we're going to have a joint question and answer session with both of them. So please do share all of your great questions in the Q&A chat box throughout both of their presentations, and then we'll have time to take them at the end. So with that, let's get started. Kurt, with your presentation. Thank you.
Great. Thanks very much, Lauren. Can you hear me okay?
Yes, we can.
Great. Okay. Well, thank you very much for including me in this, and greetings from Washington, D.C., a little further north. I'm excited to also be here because I get to do the good news part of the day. Because the reality of what I'm going to go through today is the fact that we do have a number of cost-effective, in some cases extremely beneficial when we look at the overall economic benefit of passive cooling measures available to us today. And if we were to deploy them intelligently in our communities, we can perhaps cut average air temperatures by about 1 degree centigrade, so just about 2 degrees Fahrenheit. So next slide, please. So as Lauren mentioned, I just recently, I think 2 weeks ago, joined the Adrian Arsh Rockefeller Foundation Resilience Center. And you can see some of the items that we have ongoing there. I'm very grateful to Jane for a much deeper dive into what ArshRec is doing in South Florida and Southeast Florida. And I'll have some coordinates for some of the ArshRec folks that are based in South Florida that are working on those initiatives. One thing we're doing that Jane didn't mention is an effort to categorize and possibly name heat waves in the same way we do with hurricanes, as an awareness tool, but also as a way to start to track the impacts in a more transparent way of these very dangerous and deadly weather events. Next slide, please. Okay, so it's usually not a good idea for someone without a PhD to start a presentation with an equation, but I do want to sort of, as we look at the solution sets that are out there, I wanted to call back to some of the early work that has been done to understand how heat is manifested in our community and what we can do to cool it down. This is from a paper from 1972 by Oki. And the idea here is on the left-hand side, it's the ways that energy, solar energy, is reflected in our environment. So buildings and our roads and other surfaces can gather energy from solar radiation, or we can have heat at our local, sort of in our local communities because of waste heat emissions, so things from cars or air conditioners and other sorts of processes. And so when we have that type of heat and solar radiation, several things can happen to it. The first, it can be stored, and that's when we have dark impermeable buildings storing lots of solar energy and releasing it over time that contributes to our urban heat island. Some of that can be carried away by the wind and reduce the heat in the sort of urban core, and some can be used to transfer or take water and turn it into water vapor, so latent energy. And this is sort of the theory behind evaporative cooling and evapotranspiration. Next slide, please. So what does that mean in terms of the technologies that are out there today? So a lot of the graphics you're going to see today come from a primer that we did with the World Bank that looks at individual measures, how they work in great detail, their costs and that sort of thing. So to get into a real deep dive, I'll put in the chat at the end the URL for that paper if you really want to dig in there. But we really broke this into two basic buckets. We've got sort of passive non-mechanical cooling solutions, the kind of things you do outside that affect the temperatures inside and also the average air temperature. And then also active energy efficient cooling solutions. So there we get into making decisions that can help us reduce waste heat, electrifying our vehicle fleet, that sort of thing, and using more energy efficient mechanical cooling in the first place. But the buckets sort of break into, I'd say, 2 or 2.5 categories. The first is albedo management, or managing the amount of solar energy that is absorbed by our buildings. And we primarily do that by increasing the color or lightening the color of our roofs, our walls, and increasingly our roadways. This can be done by simply putting on a lighter colored shingle, for example, on a single family home. In some cases, there are more advanced products where they look dark, but they're actually reflecting more of the sun's energy in the near infrared spectrum. So you're getting a green or a red or a brown color that's actually substantially more reflective than a traditional pigment might be. And then the second big bucket is permeable surfaces and shade. Like, I guess that's the other half piece, is the shade piece. And here what we're doing is we're taking the solar energy and using it instead of to heat the building surface or to heat the air to move from water to water vapor. And again, it's the same types of applications: green roofs, green walls. Depending on where they're used, sometimes permeable pavements can contribute here. And then the big one is, of course, tree canopy, both street trees and trees on individual properties that, if planted strategically, can help reduce the energy load of a building. That can provide shade in important parts of the day and that sort of thing. And then, of course, as we talked about, just with wind movement and other sorts of things, there's also just urban design that, especially in areas where there's lots of new development, we can be mindful of how we're building buildings, how we're building on the site, how we're building in communities, so that we're allowing the natural wind flows to move through those neighborhoods and hopefully move that heat out of those dense urban neighborhoods. Next slide, please. So I won't go into all the details here, but just to say that what we've sort of described as sort of the buffet, or these are sort of the steam tables at the picnic, and individual communities will select different sets of these that will work in their local context. In a dry, arid location, we may see less green roofs, for example, whereas in South Florida, it may be a much more useful solution. So we have the sort of common sets of interventions from passive cooling available to us, but how we select the ones that we will use will differ by location, both because of climate, because of availability, because of existing development and those sorts of things. But we sort of had a common buffet table to work from. Next slide, please. I'm just going to go very quickly here. I'm not going to spend a ton of time here, but just to dig in a little bit more detail on how this works. So with solar reflectivity, when the sun's energy hits the surface, whether that be a pavement or a roof or a wall, it really has a couple different things that can happen to it. The orange bar shows that much of that sun's energy can be absorbed by the roof, and it could be then transmitted into the air above the roof or into the atmosphere. Some of that energy will transmit into the building, and that depends on how much insulation the building has, and warm the inside of the building. And then, at least on a dark roof, a relatively small amount of that energy will be reflected as sunlight out into the great heat sink of space. And so the concept here is, if we can increase the amount of energy that's being reflected out into space and not heating up our buildings or heating up the air around our buildings, that actually creates a cooling effect. Next slide, please. And as it turns out, this effect is I think probably the base, at least for us, the base thing we should be doing in our communities, because it's applicable on nearly every roof and surface type. There are products available now that address just about every type of roof, with the exception, I think, of thatched roofing, which is cool to begin with. When they up through, certainly in Miami and all the way up through even parts of Canada, there's energy savings when cooling is present. They promote global cooling. They can reduce indoor air temperatures on, in some cases by a substantial amount. We've seen as high as 9 degrees Celsius in certain factory applications in Indonesia. They are cost effective. So as I mentioned, the example being with asphalt shingle roofs, you can simply shift to a lighter gray shingle, and it's essentially the same price. And even a dark shingle that reflects more is about 7 to 10% more expensive. So these are cost-effective solutions, and particularly when we start to think about the overall benefits they create in our communities and start to value those appropriately, these are really economic no-brainers in addition to health no-brainers. Next slide, please. There are, of course, some things to consider. This is not so much an issue in Miami, but in some markets, you can increase the amount of heating demand you need when you cool a building's surface. So that is an issue in northern climates. Reflectivity on a roof changes over time, particularly in a climate like southern Florida, where you get a lot of biological deposits on the roof, mold and mildew, things like that. You can reduce the effectiveness of the roof over time. Now, that's built into how we include these in the code, so that to some extent, that's built into the sort of levels that you would set for reflectivity, but nonetheless, that can be an issue in high humid climates in particular. If you're looking for energy savings, the amount of insulation in the building is going to matter. So if you have a lightly insulated building, the color of the roof is going to make a much bigger difference than if it's a heavily insulated roof. And then in some cases, not so much roofs, but sometimes with roads and walls, there can be the potential to reflect some of the solar radiation onto other buildings and pedestrians, which may have a negative effect on energy savings or on human comfort. This tends to be overstated, I think, because the radiation, the reflectivity is diffuse in nature. But it is an issue if you've got a lot of buildings very close to a street, let's say, that you've made cool, with your low insulation, lots of windows, and no structures or trees between the building and the road. You may need to consider, in those types of urban canyon situations, whether reflectivity is the right choice for that particular stretch of roadway or that particular building. And some people don't like the way a white roof looks. That's certainly the reality we've been dealing with since these have been in the marketplace for 30 plus years. And next slide, please. So the other aspect of this is the cooling by evaporation, and it's the same basic idea here. Is we can modify our roofs, our walls, and our pavements to retain water that can then be evaporated by solar energy. These surfaces tend to be substantially cooler than a traditional roof. They also provide an insulation benefit depending on the type of green roof it is. So you're getting kind of a little bit more of a bang for your buck when you're doing a green roof. They also tend to be a little more expensive. Next slide, please. And I covered this already, but how the cooling works when it's through evaporation. And we'll talk about some of the considerations there. But obviously, one of the key opportunities here is to increase our shade cover in our cities, both through natural solutions like trees planted strategically, but also with artificial shade structures that we're seeing increasingly used in certain places. Next slide, please. And I think there's a great paper by the Nature Conservancy and their chief scientist, Rob McDonald, that really digs into the full spectrum of ecosystem services that the green environment, that nature-based solutions provide. I think a lot of these are fairly obvious, but they're not always valued appropriately in the way we make decisions about our green space and our opportunities to increase that green space. But everything from energy savings to localized cooling from shade, but also just improved human life by improving the spiritual connection to the space that the trees are planted in, and those sorts of things. So it really runs the gamut from easy to quantify to much harder to quantify. Next slide, please. And just like with the reflective solutions, there are certain considerations. Now, I say considerations not to say that we shouldn't do these things, but it's that they are place-based things we need to consider in terms of applicability. Then that's what we're referring to here. So it doesn't mean that we shouldn't do them. It just means that these are the things we need to think about as we're planning these types of interventions. The first is, especially if it's a retrofit, can the building support the weight of a green roof? And there are opportunities to put on lighter green roofs, lighter in weight green roofs, that mitigate this to some extent, but they are less applicable than a white roof because of that structural issue. Is there enough water in the area, precipitation and others, to support the growth of that roof or wall medium, especially in the first several years of its life? The competing effects on thermal comfort. So this really gets to the fact that cooling via evaporation reduces the temperature but it does increase the dew point, or increases the humidity. And so there's a little bit of human comfort measured through apparent temperature that you're giving up when you're increasing humidity. At least in the work that we've done with Larry, who I'm sure we'll talk about this, it doesn't overtake the net benefit. There's always a net benefit to cooling, but there is a little bit of a give back there due to increased humidity. And cool roofs, and especially cool walls, excuse me, green roofs and green walls are more expensive still. Next slide, please. And this gets to some of the same ideas around use of trees and park space. I won't belabor these, they're very similar. One thing I would mention here, though, is, and increasingly we're seeing this in work in Guadalajara and elsewhere, around proper plant selection and planning the supply chain for trees that will be adaptable and resilient to a changing climate. And so in Guadalajara, for example, they're working with local nurseries to essentially replant with trees that will be beneficial in 15, 20 years, and working with them to make sure that there's a stock of those trees available that will survive in the future climate. So that's an important piece of this, I think, that we didn't cover in the previous slide. Next slide, please. And finally, again, this is, I think, maybe less applicable here where our cities are fairly well built up, but there are urban design opportunities here to improve the ventilation of our communities, and that doing so has pretty substantial benefits in terms of cooling that's available to us. Next slide, please. Okay, well, that's all I had for today. I really appreciate your time. I've included here the coordinates for Rose Mann and Rick Miller, who are my colleagues based in South Florida and are working with Jane and others there on some of the work that's happening with RSROC and on heat resilience there. So if there's any specific questions there, I'm happy to make a connection with them. And I thank you for your time.
Great, thank you, Kurt. I think we are going to just move right over to Larry. Thanks, Larry.
Thank you, Lauren. How are you? And thanks for having me. It's always a pleasure to work with Kurt, and I always love hearing what he has to say. But I want to start by not misrepresenting myself. I am no longer a professor at the University of Miami's Department of Public Health Sciences. I resigned that position 2 years ago to concentrate on research work. So I now have my own company called Applied Climatologists Incorporated. And also I am the co-founder of the Los Angeles Urban Cooling Collaborative, which I want to talk about today, the work we've done in Los Angeles, bringing together disparate people to work on how we can cool LA effectively. And I am also working with RSROC. I am funded by them to be their chief heat science advisor. I'm the guy with my team who's going to be developing the heat ranking that Kurt just talked about in the previous talk. Now, I don't have time to talk about that here, but tomorrow I've been invited by the Miami Climate Alliance, their climate and health working group that I belong to, at 4 p.m. And I will be talking specifically about ranking because Miami-Dade is one of our pilot areas that we're working with. So if anyone would like that Zoom information, you're more than welcome to come on board and listen in. Next slide. So some of this has been covered. None of us knew what the other person was going to say, but I do think this picture points out one of the problems that we have in urban areas, especially between poorer, more densely populated parts and more open parts. And I'll be talking more specifically about Los Angeles in this presentation. If you look at the difference between Watts and Bel Air, I'm actually surprised Watts even has 10% tree cover, but this is what we found. You could see the difference is absolutely astounding. So it's not hard to know which of these two areas is going to suffer the most during an excessive heat event, especially because of urban heat island effects that Kurt was talking about. Next slide. So what we have done, and I'm really proud of this, we have developed a Los Angeles Urban Cooling Collaborative, where we brought together disparate groups. Some are nonprofits, some are consulting companies, some are government agencies, academics, and so on, private enterprise. We brought them all together and formed the LA Urban Cooling Collaborative about 3 or 4 years ago, and you can see the groups involved. Applied Climatologist is mine. Climate Resolve is a big climate-oriented group in Los Angeles, as is Tree People, which is involved in planting trees. Then you see the academic groups involved, and the project was funded by the U.S. Forest Service to determine how increasing tree canopy and increasing surface albedo will actually cool the urban core of Los Angeles. By the way, amazingly enough, a private school, Harvard Westlake High School, put $100,000 toward this project, and it was to their benefit. We used some of their students on some of the projects, but it was an interesting and innovative way for a school to be involved in a very large contract. Next slide. So just some quick facts about heat and health that some of you may or may not know. I think you all know that heat is the leading weather-related cause of death in the US by far. It outstrips hurricanes, tornadoes, lightning, and any other weather-related cause. And on an average year, we have about 1,500 heat-related deaths. Many of them are not recorded as heat-related because they're heart attacks, strokes, or respiratory failure, and a medical examiner can't tell that they're specifically related to heat. We all know that urban areas are particularly sensitive to heat, especially in non-tropical areas. Now, Miami has a heat problem. There's no doubt about it, but its heat problem is not as bad as New York's, Philadelphia's, St. Louis's, or Chicago's, because those are places that have, and we'll talk about this in a second, high summer climate variability. We all know the urban heat island contributes to the sensitivity, and we all know that the vulnerability of people varies among cities and neighborhoods, which is one of the things we wanted to work on with LAUCC. Now I want to bring up this very important point. More than the heat itself, summer climate variability is the most important factor in terms of negative health outcomes during heat waves. So think of where Kurt is in Washington or in New York, where the average high is 85 degrees in July, and then all of a sudden you get a monster heat wave that's 101, 102 or whatever. That's what kills the people. The unexpected high variability of the weather, which is more important in some ways than what we have, which is constantly hot. Although there are heat waves in Miami, and I don't want to minimize them, but I can tell you for a fact, because we've worked in both cities, more people die of the heat in Toronto than they do in the equator in Singapore. And this is really one of those developed world problems, more so than developing, except in India, especially in northern India, in New Delhi, and in big Chinese cities where they have a similar problem because they're in the mid-latitudes. And we also know that extended heat events and nighttime temperatures are very important contributors. But most importantly, what I want to talk about today is we can improve the city's environment to lessen the negative heat health impact of heat. Today, we have the technology to cool cities significantly and lessen their health impact. And that's what I'd like to talk about. Next slide. So just to show you that heat is no trivial matter, this is not heat-related deaths. This is all-cause mortality deaths for June through August, 1979 to 1995 in Chicago. To do our work, we sift through all kinds of mortality data, and we have the mortality data for all over the country, county by county. So I just took a portion of it out for Chicago, Cook County, and I wanted to show it to you. We just strung together Junes and August. So every year it's just June through August, no winter data at all, just those months. And you can see a rather steady 3 deaths per 100,000 through most of this period in Chicago, except for 3 heat waves that occurred in 83, 86, and 88, where it jumps up. Now you might say, well, that isn't such a big jump, but Cook County and the nearby urban counties constitute about 6 million people. So if you go from 3 deaths per 100,000 to 5 deaths per 100,000, that little blip of 2 deaths per 100,000 is a lot of deaths because there are 100,000s in the Chicago urban area. So 2 times 60, that little blip in 1983 is 120 deaths of all causes, most of which are missed by the medical examiner. And then, of course, there was the gigantic heat wave of 95, which was written up by everyone. Look where one day went to 13 or 14 per 100,000. So we were 10 or 11 per 100,000 above the baseline of 3. Now you're talking about 630 or 660 extra deaths in this 6 million area population. And by the way, that wasn't the only day that was up there. We estimated there were 800 to 900 deaths alone in Chicago in 1995. So you can be assured the country had much more than 1,500 heat-related deaths if 900 of them were in Chicago alone during the year of 1995. Next slide. Okay, so we are synoptic climatologists, and the way we look at weather is not just looking at temperature and humidity and cloud cover. We put every day into an air mass type, and you know the major air masses. You've heard of the Bermuda High and the hot humid air mass that occurs there. We call that moist tropical plus. Then there's the air mass that comes in from the west that particularly doesn't affect Miami at all, but it does affect more northerly areas, heat events that go across from the desert because of certain favorable wind patterns. And then as they descend the Rockies, they get even hotter because descending air gets hotter. It's very hot, dry, transparent atmosphere. We call that dry tropical air, which reaches the East Coast. And those are the air masses that approach 100 and sometimes exceed 100 in the Eastern United States, as well as in the Midwest. The moist tropical ones don't get quite that hot, but the overnight temperatures are warm. And so if you have a Miami type day in New York or Philadelphia, where the minimum temperature doesn't go much below 80, those conditions are unusual for those areas and create major havoc. Next slide. So just to show you how much havoc it does create, I just made a simple little slide of 5 cities we work with. New York, 11% of the days are in either the dry tropical or moist tropical plus. That's what that 11% frequency is. On average, when there is a dry tropical day, New York's mortality goes up over 16 deaths. Some days go up 30, some days don't go up at all, but the average is 16 deaths. That's 7% above the baseline. So the air mass alone is contributing to a 7% increase in mortality. Moist tropical plus, it's about the same. And sometimes it's the same for both air masses. Sometimes it's worse for one or the other. Los Angeles gets these air masses more rarely, but when they occur, we do get a 5% increase in mortality. Notice Phoenix's number. You have to go to a DT plus super plus air mass. That only happens 1% of the time. Now, there is an increase in mortality when that happens, but there is no moist tropical in Phoenix. And so you really don't have as many deaths there as, say, Rome, where 11% of the days are in these air masses. This is a city with very little green space, a lot of concrete, as you know, if you've been to Rome, dense population. We have mortality going up on average 14% for every dry tropical day and a little bit less for moist tropical plus. And then there's that Toronto statistic. You would think Toronto would not be sensitive, but remember, there's less air conditioning there. People are not adapted to the heat. The urban structure is not adapted to heat. And so you have a real problem in Toronto. Next slide. So I will just skip through this because Kurt did such a good job. Some of our money comes from the 3M Corporation, which makes these granules that go into the roofs that reflect more energy. Next slide. And so what we did is we tested prescriptions for Los Angeles in our LAUCC project of increasing tree canopy and increasing solar reflectance, or the albedo of roofs and pavements. And we did this on several scales. We did it for countywide analysis, district analysis, climate change analysis, and national implications. Next slide. For countywide, we assumed we had the same prescriptions for the whole county. For the district level, we divided the area into socially homogeneous districts within LA County separately, so we could see how socioeconomic factors can affect these things. And I think we should do something like this for Miami-Dade as well, and see how heat and ameliorating heat can affect Miami-Dade County. We're now beginning with southern Wisconsin to do something similar to this. Next slide. So these are our 4 prescriptions. They're actually scenarios. Number 1, low increase in tree cover, but high solar reflectance. We wanted to see which affects the climate and the health more, then high tree cover and low reflectance. And then there's prescription 4, which is a high, where both of them are increased a lot. That's the pie in the sky scenario to see what would happen. Next slide. We picked 4 air masses, and one reason I like to evaluate, and one reason I like using air masses, and we did this for LA County, is that we can divide them up, the air masses up. And so we have one heat wave that's all hot and humid. We have one that's a mixture. We have one that's not that extreme. And then we have one heat wave that's hot, dry, Santa Ana, which is the hottest air mass that hits LA. It's dominated by desert air from the east. And those are always the hottest days in LA. We're gonna get to 105 in Santa Monica and in West LA, even where the rich people live. Next slide. So we did some modeling. This was done by my colleague, Dave Saylor at Arizona State. And you could see this is using RX1, the low tree cover, high reflectance. Even that cools areas significantly. And you could see 3 times during the day, where especially at 1 p.m. during the hottest part of the day, we get most of the cooling. Then the winds usually pick up, there's a sea breeze, and then it begins to dissipate. But if you can cool places by 1 or 2 degrees centigrade in the middle of the day, that is sufficient to maybe saves a lot of lives, because you're not going to be above the threshold of health problems under that circumstance. Next slide. So just to show you quickly how we did this, there's on the top, going downward, our first, that's baseline, that's with no cooling scenarios at all, RX 1, 2, 3, and 4. You will see that these are 4 days during that Santa Ana heat wave that we actually changed the air mass from a dry tropical, as we went into the higher and more pie in the sky type of scenarios, to dry moderate. And then when you see the yellow line that says mortality increase, we estimated that 5 people died on 9/26. You could see that that went down to 0 because we were able to cool by a degree or so, or 1.5 degrees centigrade. That's enough to be below the threshold of death. And you can see for all 4 days, the number of deaths go down as you move to the right and go to the more stringent scenarios. As a matter of fact, at the bottom where it says mean 4-day increase in mortality, on RX0, the baseline, we estimated a 12.4 increase in deaths by average, 12.4%. By the way, there's 150 people who die every day in Los Angeles. So over that 4-day heat wave, 12.4% of 600 total deaths is 74 extra deaths. In the pie in the sky scenario, which is realistic, we can reduce that to 52 deaths. So we estimated that we could have saved 22 lives during the single heat wave in Los Angeles if we would have increased the albedo and the tree cover by the amount of prescription number 4. Next slide. Then we divided LA into neighborhoods. We concentrated on 11 of 18 neighborhoods, and you could see that they are all different in terms of their demographic, although they were generally homogeneous demographically. Areas 5, 6, 10, 11, those are the areas that have high dense populations and high minority populations. And so and 1 as well. And we wanted to see what happened there. Next slide. And using the same approach, this is for the 4th scenario. The darker color is the greatest reduction in mortality. And you can see that we reduced during this heat wave for that 4 or 5 day event, we reduced mortality by somewhere between 20 to 40% in a lot of these areas. A couple were non-intuitive. Number 18 is the Simi Valley. That's a relatively wealthy area. Number 16 is a very hot area in the northern part of the San Fernando Valley. But 5, 6, 11, and 1 all came out high. 10, we're still trying to figure out. That's a very sensitive area, but did not come out high. And we think maybe because it's a highly industrialized area with less people. Next slide. So you can see we can now divide areas of the city and see the most vulnerable areas. Why not do this for Miami-Dade? Then finally, what we did is we wanted to see how many years we could delay climate change induced warning. So for prescription 1 over all of LA County, we could reduce the temperature on average by 1.1 degrees C. Using the business as usual emissions scenario that IPCC uses, which is RCP 8.5, it'll take 28 years to increase the temperature by 1.1 degrees C. So using prescription 1, we can therefore delay global warming by 28 degrees if we could cool the city by 1.1 degree. And then when you look at RX4, that estimates of the IPCC that it's going to be a 1.7 degree increase under business as usual, but the RX4 cools us by 1.7 degrees. That's a 43-year delay in climate change if we use RX4 and can achieve it. And if you use moderate mitigation, where temperatures are supposed to rise more slowly, obviously you're going to delay things even longer. So figure a realistic thing would be somewhere between not doing anything, which is business as usual, and moderate mitigation. We can delay climate change in the cities using present technology by decades. Next slide. Let's go to the last one, because I just want to end it this way. Lower income, more densely populated districts are generally demonstrating the greatest increases in heat-related mortality. They also showed by their darkness and color the greatest benefit of cool solutions. We had some unexplained districts, but we're going to go look into those. Thus, using cool solutions can delay climate change by at least several decades in Los Angeles. And last slide. The importance of heat upon human health cannot be underestimated, and we need to gain a better understanding of the regionality of the problem, which is what's lacking, because it's hard to get zip code level mortality and morbidity data. We're just starting to get it now. And I always like to say to my friends, I live on Marco Island, which is a rather politically conservative place, and many of the people here don't believe in climate change as a problem, at least human-induced climate change. And I tell them that we must emphasize that heat is already the largest weather-related killer. And this is why we need to go to action immediately. We have ways of mitigating heat and its impacts on the environment right now. And I very much want to emphasize that in this particular talk. And that's what we want to do the heat wave categorization for, because we want to divide heat waves into those that kill a lot of people, kill a mid-range of people, and don't kill as much people. So we would have 3 levels of interventions. And finally, and most importantly, and I think we can do this in Miami-Dade as well, academics, the private sector, government, and nonprofits must unite, like LAUCC, the Los Angeles Urban Cooling Collaborative, to tackle this particular problem and come up with adaptation or mitigation policy options. That's it for me.
Thank you, Larry. Fantastic. I'm going to invite Kurt to join us here again, and you can stop sharing the slides so we're all here. So fantastic. So we do have several questions, some of them may be specific to each of you, but I think probably generally either of you could tackle most of them. Kirk, you talked about, this kind of common buffet, if you will, or table of options or interventions that are available to cities. But talk a little bit more about what are the best approaches for local governments in terms of prioritizing where to begin, what solutions really make sense for their communities. What are the types of data or information that they really need to get their hands around to be able to make those types of prioritization decisions?
Sure, great question. I guess for me, I would go back to something that Jane Gilbert said in her talk, which is just the strengthening of the built environment to build its heat resilience. And so the base level for me with that is making sure the buildings are as thermally comfortable as possible, primarily with reflective surfaces. Where we can afford to do other things, we should do those too. And with shade trees as well, strategically placed around properties so that they provide shade to the structure. So I think those are sort of the first level. And because of that, there's a play here for, to the extent that the municipalities have control of their building codes, are able to set building codes. This is an area where, especially for residential, single-family residential homes, moving to a lighter or more reflective roof is going to be really critical. We've seen this in LA, for example. So LA has a steep slope roof ordinance. It's about 25% reflective. Your average, asphalt roof is like 10 to 15% reflective, let's say. So it's not a huge increase. It's not going to a white roof. It is really like a medium gray color. And that action in a community as large as LA, it's about a 6 million person market when you factor in the county, has substantially increased the amount of product available and also brought the cost down, which is really important. Then on the human side, I'd point out a program from San Antonio called Under One Roof. And this program really was aimed at single family income qualified homes. And what's important about it is they didn't go and put on some high tech roof. They just shifted to a lighter colored shingle. So it's the same exact product, just a different color. And doing so, they found that in some of the homes that that had air conditioning or were struggling to use air conditioning because of the economic burden of it, they were seeing savings of $900, $1,000, $1,100 a year in these households by switching there. So there's a huge opportunity here with just those kind of basic interventions in our built environment.
And what you're saying, if I'm understanding you correctly, Kurt, is that if more counties and large city governments are moving in this direction and procuring more of these materials, that we'll see a lower cost of these materials in the long run.
Yeah, I think there's a regulatory aspect to this. There's incentives, making sure there are rebates in many cases for these types of things that are built into energy efficiency programs, making those reflect the actual value that these solutions deliver would, I think, spur the market as well. So there's a lot we can do, but I think where it really gets down to it is we need to make sure we're recognizing the full economic value of these measures in what we're doing, and right now we're not. If we're just focused on energy, that's really only about 25% of a cool roof or a green roof's benefit. It comes from the energy piece. And so when so we have to do a better job of fully valuing that so that we start to capture that in our prioritization of our programs and the sort of size of those programs and the generosity of those rebates and incentives, for example.
Mm-hmm, mm-hmm. Larry, we talked a little bit about this earlier with Chris, but you touched on it again, just the need for additional data, and in particular, zip code level mortality data. This seems like a really critical piece that, from my understanding, is missing in a lot of locations. How do we get there? What is needed in the places you've worked where they're doing this? And we're going to hear a little bit more about this from Maricopa County in a bit, but how do we bring these pieces together?
Yeah, normally when we need the data, we get it from a local university department of epidemiology or public health. We work with the UCLA School of Public Health, and they were able to get the data, which, by the way, is housed by the state. We wished it was housed by the county. That would make it a lot easier, but the county has to appeal to the state of California to get us those data. Then we have to fill out privacy forms to make sure that, in fact, you're not invading anyone's privacy. So it's always difficult to get. What is easier to get are the county-wide data, which is what has been used in the projects that I just showed you, except for when we divided LA up in districts. We had a social scientist team to help us homogenize the districts socioeconomically, and then we took those zip codes and just added up the mortality data within those.
But my property. Well, there's been a lot of comings and goings.
Whoops. Anyway, that's basically the way we do it at this particular time. And it isn't easy, but go to the universities first, and they're going to start the wheels going, and then to the county government.
Great. So talk to us a little bit about solar. Down here in Southeast Florida and across Florida in general, we are really trying to move towards a much greater proportion of our power coming from solar energy. We are the Sunshine State. Have there been any good studies on high penetration of rooftop solar in densely packed neighborhoods in terms of how that influences the heat of those communities?
Yeah, let me just say one thing about that. My son lives in Monroe, New York, north of New York City, and I'd say 30 to 40% of the houses have solar panels on them. I live in Collier County, Florida, and I see almost no solar panels on the houses. And to this moment, I cannot understand why that happens to be the case, but it just is. As for the number of studies working on solar power, I do not know myself of a study that has tried to see how that might cool the city itself and how it might save lives. The link in our study that we always think is unique is the life-saving part of it, that we can estimate that we could save 20 to 30 to 40% of the lives if we use these reflective materials that Kurt and I and others have been talking about. But I don't know of any estimates that have tried to do that for solar, and I apologize, I can't give you an answer.
No problem. Kurt, do you have any thoughts, or have you seen anything related to this?
Not at a community scale. I mean, we've certainly seen, analyses of the energy benefit of cooling the roof by shading it with a solar panel, for example. We've certainly seen some where we looking at symbiotic interactions with passive cooling measures, like a green roof helping a solar panel be more be cooler and therefore more electric efficient, things like that. But I haven't seen a study on the sort of concentrated deployment in a community.
Right, interesting. Looks like an opportunity for research, right? Kurt, can you talk to us a little bit? Someone asked, what are the opportunities for improving external shading of windows in Florida? They note that windows are a major source of solar heat gain.
Yeah, so it's actually, that's a substantial opportunity. Again, that sort of falls into that artificial shade. And I mean, I certainly remember growing up in cities where having a shade over the top part of the exterior of the window was pretty common for people to have. And so we've gotten away from that. There are now certainly more technically and aesthetically interesting ways to do that. And there's actually similar to how we have a cool roof rating council, there's now a window attachment rating council that is looking specifically at this, and they might be a good resource for data for Florida specifically. I can tell you that in housing, we've been working on affordable housing in India, and the external shade, in this case, essentially just a ledge over the window, is a big part of cost effectively delivering thermal comfort inside the structure.
Interesting.
I can give you one more anecdotal bit of evidence. Living in Marco Island, our house faces southeast, and we spent $5,000 to put 3M films on our big picture windows facing southeast. And I will tell you that instantly my utility bill went down 15%. So I'm amazed by that. And I think it's obviously, I'm going to get my $5,000 back in just a few years, but I'm just giving you anecdotal evidence because I had to laugh when you asked that question. We've done that exact thing. So not the solar roof, but the films on the windows.
Right. Right. Well, that's evidence indeed. Larry, I was curious about the prescription 4 that you talk about in the study. And if I was understanding you correctly, that could correlate to something like 1 degree centigrade. What is the amount of tree canopy percentage required to get to that level of prescription? And would both the threshold for this tree canopy, whatever that is, as well as sort of the temperature threshold that you talk about wanting to get to be able to reduce heat-related mortality, are these things, are they consistent across all geographies, or do these things change based on the geography and the city? In other words, would these be different thresholds in Southeast Florida than in LA?
Yeah, let me answer the second question first. Yes, it is different geographically. There is no doubt. First of all, just the structure of the city, you can't imagine getting 30 or 35% of tree cover in Manhattan, for example, extraneous of Central Park. But you can in Los Angeles or even in Miami-Dade, where you might have a more spread out city than you would have in the large northeastern urban centers. So clearly you have to change the prescription for each area. For LA, I believe we use something in the order of 35%, which countywide, it may be 40. We'd have to look back. I don't have it in front of me right now, but it says on one of the slides, the number is actually on the slide. It's either 35 or 40, which county-wide we can achieve, but you can't do it in all neighborhoods. You saw that aerial picture of Watts. There is no way you're going to achieve anywhere near that in Watts, but you certainly can achieve it in places that don't have it now. So when we developed these prescriptions, Tree People was greatly involved, that NGO, to tell us what was realistic. And we guessed that 35 to 40% can be achievable with some effort. And that's how we arrived at that number.
Great. Well, I think we are unfortunately out of time for questions. I would love to continue to talk with you both all day, but we need to move forward. But thank you both so much for your fantastic presentations, and we will be sharing a number of the resources that you both mentioned throughout. So thank you again. So it's now my pleasure to introduce our next speaker, Kizzy Charles Guzman. Kizzy is the Deputy Director at the New York City's Mayor's Office of Climate and Sustainability, where she leads the social and environmental policy team. She also led the development of Cool Neighborhoods NYC, the city's first comprehensive strategy to address impacts of rising temperatures and heat waves. So Kizzy, thank you. We are so excited to learn from your work in New York City.
Thank you so much for having me, Lauren, and everybody. Hi, folks. Thank you for joining us. It's been a day and you're still hanging on here, so we appreciate it. It's very exciting to see so many of you interested in this work. So again, I'm Kizzy Charles Guzman from the New York City Mayor's Office of Climate and Sustainability. And my office has been working on climate policies for many years. We mandated carbon emissions reductions and retrofits in existing buildings. We're on the path to achieve carbon neutrality by 2050 and 100% clean electricity by 2040. And we're rapidly expanding renewable energy. In fact, there's 12 times more solar in New York City today than there was in 2013. And on the adaptation side, we developed the climate resiliency design guidelines so that we're on the path for all city buildings and infrastructure to be built to withstand future flooding and heat. Next slide, please. Next slide. As you heard this morning, heat is the most fatal of all extreme weather events in New York City and also in the United States. And while climate events like hurricanes get a lot more coverage, we are already enduring heat waves that are more frequent and more intense and longer in duration. This is the New York City thermal imagery map. You can see it on the right. The blue areas are cooler. So those are our water bodies, right? There's Central Park and Prospect Park. And in red areas, you have areas that are warmer, right? So those are our airports, our very dense places. So the key drivers of heat impacts in New York City include things like traffic and infrastructure. So on top of that, the New York City Panel on Climate Change projects that by the 2050s, the number of days above 90 degrees will triple. So we're facing a warmer and wetter future climate with more extreme events of all kinds. Next slide, please. And yet indoor temperatures can be up to 20 degrees higher than outdoor temperatures without air conditioning. And some neighborhoods are much warmer than others, again, due to inequities in green infrastructure and vegetation, the presence of dark and impervious surfaces, and many sources of waste heat, like traffic and industrial uses. As a result, on heat wave days, New York City sees an average of 110 direct and indirect heat-related deaths every year. And when you consider the entire warm season, so from May through September, that number jumps to 350 deaths annually. And the great majority of these effects are experienced by our seniors, mostly African-American men baking in their apartments without access to cooling or fearful of a high energy bill in substandard housing. And each of these deaths was preventable. So that knowledge gave us the impetus to develop a plan that had health and racial equity at its core, specifically to reduce disparities and vulnerability to climate change. Next slide, please. So we convened a working group of experts representing our government agencies and also members of academia and nonprofit organizations that focused on environmental, climate, and public health issues. We tasked them with identifying the best practices for heat mitigation and adaptation, and we wanted them to do so with equity at the outset so we could protect the city's most at-risk residents. This effort laid the foundation for the release of our first ever heat adaptation strategy in 2017. The idea, again, was to reduce heat-related health impacts in target neighborhoods. We called it Cool Neighborhoods New York City, and shout out to Kurt Schickman for lending us his expertise as we conducted this work. He really has been a great partner for many years. Next slide, please. So on the right, you can see some of the components of our plan, which is available online simply by Googling Cool Neighborhoods NYC. And I'm going to highlight some of those really quickly over the course of today. But first, on the left, you can see a map of New York City. The coloring on this map represents our heat vulnerability index, which was developed by our health department and researchers at Columbia University. It describes the relative risk of our neighborhoods for heat-related deaths and immediately following extreme heat events. At the time, this index was composed of 4 social and environmental factors that were associated with increased risk of death on a heat wave day. So the index considers income status, race, surface temperature, and vegetative cover. But we recently added a 5th variable to the map, and that is air conditioner prevalence. And it still looks more or less the same. But I just want you to know that as it relates to cool neighborhoods, this is the map that we used to target our investments and our interventions. And over the course of this presentation, I'm going to continue to call your attention to the areas of the map that are in red. These are the places of the city that have greater vulnerability to heat illness and death. Next slide, please. So a major part of our strategy was increasing natural infrastructure in those red areas of the map. So again, our high heat vulnerable areas. We are investing millions of dollars to plant trees in historically underserved communities. Besides planting trees strategically along city streets and small parks, we're also doing some forest restoration. And of course, the benefits of tree plantings go well beyond mitigating the urban heat island effect and relieving heat stress by increasing shade and providing cool corridors. There are also so many social co-benefits of community greening efforts. You can see in these photos the incredible shading potential of street trees. These are same locations over time. However, it takes 100 years to grow a 100-year-old tree, right? So we really have to try other approaches to try to cool our public realm. Next slide, please. We already had a citywide cool roofs program that was fully funded. So what we decided to do with our new strategy was to prioritize the roof coatings in heat vulnerable areas by targeting outreach to building owners in those communities. So the goal was to achieve clusters of light colored surfaces. And we made this program completely free for buildings that came in as a cluster and those that served a nonprofit or affordable housing or community or social service. Again, the idea is to concentrate as many roofs as possible in the geographies where we see the greatest public health and environmental impacts. Next slide, please. Here you can see the impact of this work at the local level. This is public housing in Brooklyn before and after the roof were painted white. Next slide. And yet buildings are responsible for 2/3 of the city's greenhouse gas emissions. So we knew that they had to play a role in heat mitigation. So we enacted legislation that required all new buildings and those buildings that were undergoing major roof renovations to be covered with solar panels, green roofs, or a combination of the two. Because of this policy, we expect to reduce over 1 million tons of greenhouse gas emissions by 2030. And we also expect to manage about 1 million gallons of stormwater per year. Next slide. Because we know that heat risks are unevenly distributed in our city, we also wanted to measure temperature in 14 of the city's most heat vulnerable neighborhoods. So we had about 500 air temperature locations and neighborhoods that we selected based on land use, whether it was high heat vulnerability area, and also based on our tree planting schedule and whether it had more mature trees. So we want to be able to explore those differences, right, between and within our boroughs, if there are any. Next slide. We also tried measuring indoor air temperature because we know that, again, indoor temperatures without air conditioner can be substantially higher than outdoors. So we wanted to assess that relationship. So we collected measurements of 67 residential apartments and 8 public libraries. And we chose the libraries because there are cooling centers. And what we wanted to do was to document their temperature differential and be able to plan for improvements. Next slide. And yet, unlike in other municipalities, as you heard earlier today, in New York City, most victims of heat-related deaths are actually exposed indoors. So our health department has conducted extensive surveillance of heat-related illness and death. And local studies have found that indoor temperatures in homes without air conditioner remain high for days after a heat wave, even at night, due to a building's capacity and ability to store heat. So access to air conditioning is a climate equity issue. We know that heat risk and air conditioner prevalence vary by neighborhood. In fact, despite the fact that the country's air conditioner prevalence is so high, in fact, 99% of households have it. in high-income neighborhoods, inequities persist. So in New York City, 30% of residents without AC also live in the highest poverty neighborhoods. So we conducted surveys and focus groups and learned that vulnerable people prefer to stay home even when it is dangerous for them to do that. And we also learned that our media, so our health and weather reporters during heat wave days, were showing images on TV that emphasized outdoor risk instead of indoor risk. So people didn't know to protect themselves as they should. Next slide, please. So our strategy underscores the critical role that our most trusted messengers can play in adapting to climate change. So we targeted community organizations, home health aides, health and weather reporters. They're all documented in the literature as trusted messengers in communities across America and also in New York City. So we wanted to reach those that were most at risk via their trusted messengers, and that did not have to be city government. So we targeted them. We gave, faith-based organizations, the clergy, medical professionals. We gave them emergency preparedness information and climate training so that it could actually reach those that need it inside of their homes, right where they are. So we partner with home care agencies to disseminate those messages, promote that information, but also to educate home health aides to recognize and address early signs of heat illness in their clients, okay? We want to make sure that at the end, crucial information about protective actions that people need to take to stay safe indoors are given by their caregivers, their social contacts, that we want them to be able to check on vulnerable neighbors and friends and family. So we also finally launched our Be a Buddy community-led program to disseminate those messages, and we activate them during non-emergency periods, right? So it's like a muscle, and you practice that so that during emergency periods, we can activate those check-ins and it comes as second nature to them. So all that to say, we really are working through partnerships to support organizations and those trusted messengers to help us, right, build climate resiliency. And we're trying to foster trust by using those existing resources at the community scale. Next slide, please. So with that, I just want to shift gears quickly and share some of the important challenges that we've faced. Number one, of course, perception of heat risk as a nuisance and as a future threat rather than a significant and current public health issue. So we've really had to shift our messaging around that. Another challenge is perception of air conditioning and cooling access as a luxury as opposed to life-saving medical equipment, really. Funding constraints. So often our climate dollars are closely tied to a disaster that has happened, and that tends to be things like hurricanes and coastal storms. And so we are unable to use that federal funding for heat mitigation and adaptation strategies, and that's very problematic, because that brings me to the next challenge. It really then is up to every municipality to have the political priority and the political focus and the political will in order to fund those initiatives, and that can change from time to time. So that lack of support and momentum for regulatory and policy approaches is also a key challenge. To be honest with you, after all these years of trying to secure cooling access for our most vulnerable New Yorkers, it actually took a pandemic, the COVID-19 pandemic, to be able to get the momentum and the attention that we needed, both from the state and our city, to be able to put the system in place to actually do an air conditioner distribution program and to provide utility assistance and subsidies to low-income New Yorkers so they could safely stay indoors last summer as we had stay-at-home orders in place. Next slide, please. Lastly, I just want to also share some key lessons because not all was bad. We've been at this since 2015, as you heard. And I think it's really important for those of you on the line that are practitioners to develop those data-driven plans and policies and programs that are using the climate science that you've heard today, but also looking at your own cities and municipalities' environmental and social indicators, and to layer that with health outcome data. So your health departments are key partners as you develop policies and programs that can withstand the test of time, and as you are trying to fundraise in order to have those initiatives implemented. The second lesson I would share is to identify opportunities to put your budgets to work in service of vulnerable people first. I think it's a mistake to look at citywide programming as we just need it to be the same everywhere. That is equality, but that is not equity. Instead, we really need to be thinking about who's most affected and how do we reach them first. Lastly, reassess existing programs and derive more social value from investments you already have in place. So a good example of how we did that was roofs, right? Like we already had a fully funded strategy that had been on the books, but we knew that one roof here and one 10 blocks away was less optimal for vulnerability mitigation, right, than if we had those clusters. And so we took already existing funding and we did, at that point it's a policy, right? It's someone saying we're going to do specialized outreach to building owners in these target neighborhoods. And I, of course, can't emphasize enough how a clean environment and quality housing, those are basic rights. Those are not the same thing as amenities, and certainly they should not be considered luxuries for high-income neighborhoods. So I want to leave you with just a last thing, which is about engaging people in preparedness efforts. So an emergency, it's not the time to train people. It is not the time to solicit volunteers. It is not the time to scramble and try to keep each other safe and protected. Instead, you want to enlist buddies so that as we face chronic events like heat, which again, heat waves are happening multiple times every single summer, if you enlist those buddies, during blue sky scenarios, it will lead to more resilient communities, and you will build more of that social cohesion, that social capital that is so important. A key way that we did that as government was to fund organizations that already had those deep ties to the communities. So we can't expect them to do it for free. Organizing takes time and so much effort, and we really need to enlist those community and neighborhood association groups as partners in that, because the climate emergency merits that level of engagement and they need our support. So I will stop there. Next slide, please. I want to thank you for joining me today, and please feel free to reach out to me with any questions. There's my email address at the bottom of the slide, and shout out to my team here in New York. They're awesome, and I couldn't have done it without them. So I'll stop there. Thank you.
Wonderful, Kizzy. Thank you so much. Just a wealth of resources. I have included the Cool Neighborhoods NYC report in the chat, and I certainly encourage everybody to check that out. That report is really impressive, and hopefully something that our communities here in Southeast Florida can aspire towards into the future. So have some questions for you, Kizzy. First off, in terms of just centering equity within the work that you've done and not being really critical, have you found the index that you mentioned with the 5 indicators or variables? I think you mentioned income, race, temperature, tree canopy, and access to AC, if I caught them all. Okay.
Yeah.
Would you, have you found that, you talked about expanding it from 4 to 5, but have you found that to be sufficiently refined in order to allow you to sort of target the populations that are most at risk? And do you envision that these kind of main indicators could be generally transferable to other regions to employ a similar kind of index, or do you think that that needs to be really localized?
Yeah, that's an interesting question. Thank you for that, Lauren. Listen, I think that you do not need a SOVI style, like you don't need 25 indicators, 29 indicators to tell you what your health department already knows, which is that heat illness and heat death is actually driven by poverty and inability to seek a cooler space. And poverty and race are so closely intertwined because of our decades and decades worth of super racist policies and the disenfranchising policies that have created redline communities and that have distributed environmental amenities in an unequal way. So I think that if you're a municipality that does not have a health department with strong surveillance mechanisms, and most do, right? I think that using the variables that we've used in New York City is a great place to start. At the end, many municipalities, like, so some of the environmental indicators that I shared, right? So like surface temperature and vegetative cover. We know that information because we have, say, LiDAR data to know about our vegetation. So not every municipality is going to have that. But your parks department has a strong sense of what areas of your city have more forested areas than others. So enlist them as a partner, right? Surface temperature. We have some level of temperature monitoring in our city, but not every city does. Some cities might have to partner with a local academic institution because then they can maybe access satellite information, right, on temperature. And so I think that part of this is you really need to start by figuring out what is available at your municipality. And I think that these are the indicators that in the literature, which is what we were trying to achieve, right? Like a very simple index that where every single indicator was in the literature documented as being closely tied to the health outcome. And that was either heat-related death or heat-related illness. So I think that you will find that most municipalities have a similar story to tell. Right. Keeping it simple feels important for sure.
Absolutely. One of the things that hasn't been so simple here in Southeast Florida is getting access to AC data across our local governments. How did you guys find barriers to getting access to this information, and how did you ultimately get it if you did? How did you work around it if you didn't? And then I guess a similar or related question is, do you have a handle on sort of utility disconnect data and how that is, correlated to heat stress incidents and heat related impacts?
Interesting. Okay, I'll take those two things separately. So definitively understanding air conditioner prevalence is difficult. Okay, it is very difficult. Also because it changes so often. You can have an AC today and then you got rid of it next summer. It changes. You might have an air conditioner that sticks out your window, and so you could see it, or you might just have actually central air conditioner, or you might have an air conditioner that lives inside your home altogether, right? Like the portable ones. So it's really
or you might not be able to afford to use it.
Exactly. So it is very hard to tell. These are all estimates. Locally, what we have in place is the housing vacancy survey, which our housing department coordinates. And so we do have a question in there that allows us to extrapolate our air conditioner prevalence locally, right? So that is one way that you could do it. If you were able to secure some funding to even do a telephone survey of a handful of your counties, you might be able to kind of extrapolate that data up, right? So that might be a way to handle it. So for us, it is an estimate, and we do have a survey in place that is annual and that we derive our data from. Your second question is about utility disconnections. And for that, we have actually spent a lot of our time advocating for these types of changes to our disconnection policies and all of that with our Public Service Commission at the state level, and also partnering with our local utilities. So I wonder if your local utilities would actually have more granular data that they might be able to share with a city official, right? So I think that building those partnerships is hard and takes time, but it's also really important because then it gives you the data that you will need to be able to make those cases. For us, again, last summer during COVID, we were able to successfully petition the Public Service Commission to not only expand the low-income utility assistance program, but also to deal with those disconnection issues. So they wouldn't turn off the people's power due to non-payment during heat wave periods. And we got them also to not charge the fines in order to reconnect them to power. And again, it's just about trying to keep people alive during what was already a very bad situation of having to stay indoors during dangerously hot weather.
Yeah, we were facing similar last summer, height of COVID and heat waves, and it was definitely a very difficult time for a lot of folks in our community.
Yeah.
Last question, Kizzy, and I regret that it is, because I again have so much to ask you, and I think we have so much to learn from you. On the topic of social cohesion and the work that you did on sorry about that, you know, the trusted messengers and the buddy program, you know, this seemed to me like really kind of ongoing work, not just a once and a done sort of situation. You know, you train the home health aides and the other partners, and then they go off and they do this work, but more something that's ongoing engagement, collaboration, and partnership. So how is that working? Are you guys, is this now just a line item in your annual budget, or how is this kind of ongoing work being funded?
Yeah, okay. Let me start by saying and giving a huge shout out to our Department of Emergency Management, right? And also our health department. They, as of right, already have a lot of touch points with community organizations, with health services providers, with community health workers, right? And so this is work that is already, in a way, funding-wise baseline through some of those emergency preparedness activities, right? That are funded both through the city budget, but also through the federal emergency preparedness grants, right? So what we're trying to do is create a culture of sustainability and resiliency in our city agencies, whether you're public works, whether you're environmental protection, whether you are emergency management. Is about making sure that when you already have that captive audience, so those trainings are already taking place, that you're also making the connection to climate change and to the future that New Yorkers will face in the short term, and the future that they're facing today because of this acceleration, right, of global warming. So I think that's a long way of saying there are existing funding streams that would allow your municipalities to convey this level of climate training. For Be a Buddy, that was a brand new initiative, and we started it as a pilot program, and we baselined that program for just about 3 years, and then we have continued to look for funding. And part of what we're doing is, because we pass through that money to the nonprofit organizations, as the organizations now have 3 years worth of this activity as part of their day-to-day, we are also hoping that as they continue to fundraise for their own operations, that these are activities that they continue to undertake. You see what I'm saying? Like, the idea is that we don't always have to have that funding baseline year after year. We are all partners in securing those dollars and making sure that when grants become available, that we go in as a team, because I think that this is going to be an ongoing issue for sure.
Incredible work. Thank you, Kizzy. Really appreciate it.
Thanks for having me.
You're welcome. So next, I am really pleased to introduce an expert from another leading local government on heat response. Dr. Violsha Barisha is a senior epidemiologist within the Department of Public Health in Maricopa County, Arizona. That's where Phoenix is, for those who might not be as familiar with the geography out that way. We will hear from Violsha about the monitoring and heat surveillance work they've advanced and how this can help inform responses to heat risk. Thank you, Violsha. We really appreciate you being with us today.
Hello. Can you hear me?
Yes, we can.
Okay. I can't see my slides.
You can't see your slides? We're presenting your slides for you. Can you see?
Okay, great.
Are you able to see the screen?
I only see the screen with my picture, but not the slides. Okay, great. It seems like I am really sorry I am unable to use the camera. So, but I hope you can hear me very well and hear the presentation. So I apologize. Thank you for having me here today. And my presentation, as Lauren mentioned, I am with public health with the Office of Epidemiology, and all our work has been around data and its data-driven approach that we use for all kinds of climate-sensitive hazards, including heat. So what I would like today to share with you, it's mainly focused on the surveillance that we started in 2006, and also share with you the pathway that we, over the years, we built, and now we are really, these data took us also to the community engagement. Next slide, please. So for you that don't know, Maricopa County is located in the south central part of the U.S. State of Arizona, and over 4.5 million people live there, which comprise 60% of the Arizona's population. It's diverse population, mainly white, Hispanic, African American, Native American, and others. And one fact that I wanted to mention, that vulnerable communities are not uncommon in Maricopa County. More than 12% of population lives under the poverty line. However, there are neighborhoods that this percentage goes even to 50% living under the poverty line. Temperatures, environmental temperatures, one of the things is it is a public health concern in Maricopa County, and this is one of the largest centers that experiences the nation's most extreme heat. For example, environmental temperatures over 100 degrees of Celsius, of Fahrenheit, they start with May and go up to the end of October. We have on average 110 days with those temperatures. However, these temperatures have been increasing, and in 2020, for example, alone, we had 144 days of this type of temperatures. Temperatures above 110 are not uncommon, on average 26 days, but if you compare with 2020, we have 53 days of those. And also minimum temperatures that they go 90 and above degrees of Fahrenheit, 13 days on average over the years. However, in 2020, we had 28 nights. So next slide, please. Maricopa County, not only that experiences chronic heat, but also other climate sensitive hazards, which are dust storms, drought, wildfires, flash flooding, and poor air quality. All these climate sensitive hazards, they are getting worse, especially now in the face of climate change, and they pose threat to public health. So public health priority is to prevent the deaths and illness, and this perfectly aligns with our vision and mission and with our guiding principles, which collaboration, we see that collaboration is the main thing to achieve the maximum impact. Community, focused on community, on equity and accountability. Next slide, please. So as I mentioned earlier, well, our heat surveillance started in 2006. It was established, and data collection, tracking heat-related deaths and illness, not only that gave us a picture of what's the impact of heat on people's health, but also made possible for us to raise this and make the public health concern with our partners. It helped increase the partnership, it helped strengthen our collaboration, it helped later on to bring some funding, and also made possible connections, not only create connections, not only locally, but also nationally, and our network is increasing. As just I would like to make a point that funding in 2015 for the first time that we received it to make possible that we expand and go beyond heat, include other climate sensitive hazards, bring our stakeholders on board, and create climate and health program. Next slide, please. So our surveillance, we didn't have any surveillance system since 2006. However, in July of 2005, our community experienced high temperatures. And as a result of those high temperatures, we had, it was unusual year. We had a lot of deaths. Medical examiner's office was overwhelmed. In 1 month, we had total of 45 deaths, and 35 of those happening within 9 consecutive days. High temperatures, they reached 116. National Weather Service was issuing excessive heat warnings and so on. As a result of that, our community got mobilized, and Maricopa Association of Governments and City of Phoenix, they came with innovative program creating cooling centers and water distribution centers in order to alleviate the problem. Next slide. We at Public Health, we started our heat surveillance program at that time, and which since then starts in May and ends at the end of October. I can say now that it somehow became year-round. We really don't know when it starts, when it ends, because of the changes, also the months, the time when the deaths occur and so on. It has been a shift also in months compared to previous years. Our system consists in data collection, case investigation and analysis, case classification, and based on the case definition that we have, and generating weekly reports, especially during the heat season, and distributing them to our partners and our community. Next slide, please. Our data source is mainly, we rely on the data that Office of Medical Examiner provides. Those are first-hand data from or preliminary reports of death. We rely on hospital discharge data for illness. Death certificates are our gold standard. And syndromic surveillance data for recently we have incorporated, and we have information on trends, what is going on in our hospital emergency departments. Media reports we find very often very helpful data through media reports. We are also able to track some of the cases that may have not reached our system yet. Next slide, please. What do we collect? We do collect demographic information. We do collect the location where the injury has occurred and that. Is it urban, rural, indoor, outdoor, and so on. We do collect circumstances surrounding the death, such as, is it work-related? Is it recreational activity? If indoor, was AC working? What was the ambient temperature, and so on. And also multiple causes of death, medical examiner findings, and so, and many. We also have a system that we use in extracting the heat-related deaths, which relies on ICD-10 codes and also the key phrases that we have built over the years. Next slide, please. So our case definition and classification really is the source of information for that is the death certificate. Next slide. So based on the death certificate and the case definition, we classify our cases in heat caused and heat related. Heat caused are deaths that they are directly to the exposure to environmental heat. And heat related are those that a death is due to other health condition or diseases. However, heat was a contributory factor. Just to let you know, we do have another classification until they get either classified as or get confirmed as heat related or get ruled out. So we have two more classifications which are pending and also ruled out cases. Next slide. So over the years, this is when we started the surveillance, and also we, in order, sometimes from the that database, you don't get your answers. So in order to understand better the impact of heat and barriers in the community, we also employ surveys. So we have done, for example, cooling center evaluation with our visitors there that they use cooling centers. We have done the vulnerability and emergency preparedness needs assessment with the community. We have done survey with homebound individuals. We have done also survey recently, last 2 years, with mobile home communities, and also surveys with about the energy insecurity in the vulnerable communities. Next slide. So here is, this slide really shows, it's not included, unfortunately. I don't have yet finalized the year 2021. However, it's not different from 2020 at all. So there have been, since 2006, there have been more than 1,800 heat-associated deaths, confirmed heat-associated deaths. And as you can see, since 2015, we have seen that the numbers are increasing. And 2020 was exceptional with 323 confirmed deaths. As far as hospital visits, there have been 1,700 on average. However, the last few years, we have seen an increase which went to more than 2,400 hospital visits during the season. Next slide, please. This slide really shows the, I'm sorry, it doesn't show very well in here, but it really, it's not very clear, and I don't know why, but it shows the excessive heat warming days and also heat-associated deaths with low and high temperatures. The point was to show that 52% of heat-associated deaths occurred on days for which excessive heat warming has been issued. And we are working very closely with National Weather Service and with our healthcare providers, sending them the information when the excessive heat warming is issued. Next slide. I did mention that that we classify cases in heat caused and heat related, and 61% of heat associated deaths since 2006 have been classified as heat caused, which means heat was the main cause of death and compared to the contributory. Next slide. Combination of maximum and minimum temperatures it plays a role. As you can see, the average deaths per day they increase as minimum temperatures increase. Next slide. Some communities are more disproportionately affected, such as Native Americans and African Americans. Can you hear me? Next slide. Can you hear me?
Yes, we can hear you.
Okay, thank you. This is the heat wherever the poverty rate is high, also the heat indoor deaths are very high. Next slide. Why people are dying indoor? We've seen that from our investigations that 14% of our time of death, they didn't have any cooling system. However, the one that they did have, their environment was not cooled, and the reasons for that was that majority of disease, they didn't have AC, was not working, or AC was turned off, which we don't know the reason, and they didn't have electricity. Next slide. This is the slide where the indoor deaths occur mainly in the houses, but also in mobile homes, 30% of those. Next slide. Also, they are related, we see an increase of drug use in these heat-related deaths from latest years. Next slide. Homelessness has been increasing, and last year we did have the high number of homeless individuals in the community that they died of heat-related deaths. Next slide. The data helped us also create all these profiles that you can find in our annual reports, such as about the substance use or profiles living in mobile homes and so on, which they are very helpful in initiating actions for or launch any different actions in those communities. Next slide. So in 2015, I'm going to switch in here. It was the first time that we did receive some funding from Public Health Institute, and later on, very shortly, from CDC BRACE grant. And that allowed us to reach out to our partners from different sectors and host a meeting called Bridging Climate Change and Public Health and create a coalition. Next slide. Very shortly after that, the members of this group, they created the strategic plan, climate and health strategic plan for Maricopa County for 5 years, and they identified the 5 different strategic directions. We created programs, action teams were created, and projects were being in the community initiated. Next slide. So the last few years, with the help from, in this case, with the help from ASU, from Healthy Urban Environment Initiative grant, we were able to initiate a campaign about raising awareness about extreme heat, safety tips, and available community resources. And we have done that very successfully with community-based organizations, especially community health workers, that they are part of that community-based organization. We did administer surveys and provided the heat toolkit and posters with information about heat. And the good thing about this campaign is that we still keep working with them, even the project has ended, because the community always has some type of solution, some type of suggestions about what to do and how to be helped. Next slide. In South Phoenix, we have been working with another community-based organization, which is called Unlimited Potential. And this project is geared toward energy security and public health. It's supported by Robert Wood Johnson Foundation, And the goal is to understand the experience and social distribution of energy here among residents in Maricopa County, develop toolkit energy insecurity index that will be utilized by stakeholders to identify vulnerable populations in these communities, and of course, advance more collaborative policies. Next slide. So this is what we found through our survey about energy insecurity. We found that around in some communities, I did mention the vulnerable communities. So we found that 91% of the household they live under the energy burden. They are either severely or highly burdened, which means the energy burden represents the percentage of household income spent on energy bills. Next slide. Of course, some communities, they have a hardship. However, the COVID during the last year had made it even worse. Households, they lost the jobs, they had to reduce in working hours, they couldn't pay their utilities, they were unable to pay for rent, and so on. So difficulties that they were facing, these two communities that we have been working in Central Phoenix and also in South Phoenix, mainly Hispanic population. Next slide. And but one good thing from both working with both of these communities is that they felt so close working with us that they suggested some solutions, and one of them, they requested a workshop on how to maintain mobile homes and cooling systems. So our members from the energy security work group, such as utility organization, Foundation for Senior Living, and others, they came together and we organized the workshop. It was held on October 23rd, and it was very successfully completed. A lot of interest from the households, 40 households, members of households, they participated and they were very satisfied. Next slide. So next, I would like to leave you, thank you for listening, and leave you with resources listed here. We do have a heat story map in our website, and also we have a web page on bridging climate change and public health and energy insecurity. And I would like to thank all my team for the work that we do, they do and help. And so thank you again.
Thank you so much, Vilsa. Really appreciate this case study and learning from what you all have done in Maricopa for more than a decade now. It's fantastic work. Just a few quick questions for you. The first, kind of process oriented, as I know this has been tricky in other places, but how did you go about changing the death certificate processes?
Changing, I don't know what you mean, but we did not, we do have access to vital registration data, to death certificates. And then we analyze those death certificates, we extract the ones based on the ICD-10 code and also key phrases, for example. So once we have those, then we do have the case definition that we have established, and that allows us, was, for example, deceased, was it in the death certificate mentioned, as any other condition or only heat. And so based on that, we have classified them as heat cost and heat related.
Thank you.
I hope I answered your question.
Yes, you did. Thank you. And did the heat profiles that you mentioned that this data has allowed you to develop, have those profiles enabled your team and others across the county to be able to really target the interventions that you're using?
Yes, I can say they are available, for example, and we do have heat resilience group, our stakeholders from different counties, from different organizations. They meet weekly, and we share all of this information with them, and so they do have and work very closely with each jurisdiction.
Fantastic. Well, thank you again. So appreciate your time, your expertise, and your leadership on these issues, Yilsa. And I'm sure there'll be folks wanting to talk with you more about your specific experiences. So thank you. Finally, it is I'm sorry. Finally, it's my pleasure to introduce Dr. Ladd Keith, also with us from Arizona. Ladd is an assistant professor of planning and the chair of sustainable built environments at the University of Arizona. He is an interdisciplinary researcher working at the intersection of urban planning and climate change to create more sustainable and resilient cities, and is an expert on heat governance. We're grateful for your expertise, Ladd. Thank you.
Great, thank you so much, Lauren. And thank you everyone who has stuck through. I know a 3-hour webinar workshop is a lot to ask, even if it does have a break. So I appreciate everyone kind of hanging in there until the end. Next slide. Yeah, so like Lauren mentioned, my name is Ladd Keith. In addition to being an assistant professor, I'm also a research affiliate at our Southwest CLIMAS, which is the NOAA Regional Integrated Science and Assessments Program, and a co-PI of our CDC BRACE program for Arizona, which Chris had mentioned earlier. So I'll keep my fingers crossed that Florida gets good news on their proposal for that. Next slide. So kind of one of the things that got me interested in extreme heat as a topic area was about a decade ago, I was looking generally at kind of climate change in urban planning. And it was just very apparent that while cities were beginning to do more things for sea level rise, flooding, wildfires, drought, there wasn't as much information out there on how cities should actually plan for heat. And so kind of would get blank stares from planners, even in Arizona, if you talked about like, is heat something that we should be planning for? So there was one literature review a while back that looked at 3,500 climate adaptation resources by Nordgren, and that found that only 4% of those looked at extreme heat. So about 10 years ago, I started to look more specifically at extreme heat. And we did a literature review with Sarah Miro and Tess Wagner, just looking at literature for planning for extreme heat, and found that 60% of that literature had been written in the last 5 years. So you can kind of see that growing through time. And I'm sure if we added the last couple of years to this slide, we would see it continue to rise. Next slide. One important thing to note, though, is that a lot of that research that's been written so far on planning for extreme heat has been on modeling and mapping the urban heat island, which we've heard a lot about before. It is really important to understand kind of those microclimate effects and the urban climatology impacts that the built environment has on urban heat. But what I'm interested in is that 7% of research that was looking at planning processes and governance, which is only 39 papers, which is not a lot at all. And so again, that's increased a little bit more in the last couple of years, but we're still very far behind in thinking about extreme heat, how we actually implement some of these policies and some of these strategies to address it versus other climate risks. Next slide. So one project that we recently are having published is looking at a national survey of US planners. And this is the first survey of US planners specifically on extreme heat. And this is with Sarah Miro at Arizona State University. And so what we wanted to do is just do a national survey basically of planners across the United States in different climate regions and different size cities, and ask them how they were how heat was impacting their communities and what they were doing to address it. And so we had both a random sample with a response of 69 cities, and again, diverse climate regions and city sizes. And we also had a convenient sample, and I'll just focus on the random sample for the purposes of saving time. Next slide. So we asked questions about what their concern was for heat impacts to different sectors, and then their concern about different heat contributors to extreme heat in their communities. I think overall concern for extreme heat was pretty high for most of the responses. And interestingly, planners were more concerned about the climate change impacts to extreme heat than they were about the urban heat island as a contributor to extreme heat, which I think we could have a whole discussion about. But good that they're aware of the climate change related impacts, but of course their control, the local planners' control over the urban heat island is arguably a little bit stronger than global climate change with greenhouse gas emissions. And so maybe a missed opportunity there, or something that we could look for in the future, that planners actually do have a pretty strong connection with that urban heat island. Next slide. We asked about the reported impacts that they were already experiencing. And again, this was a nationwide survey, and there were some regional differences, but energy and water use increases were some of the top impacts reported. Concern over urban vegetation and wildlife. And then interestingly, public health was number 4 on this list. Now, the one difference is with that convenience sample, which was skewed much more towards kind of environmentally progressive cities along the coasts, public health and quality of life was much more higher ranked. But in some of the more conservative cities and smaller cities and medium-sized cities, energy and water use were higher reported heat impacts. I think an interesting thing is that a lot of the economic kind of correlation stuff, so economic productivity, tourism, labor productivity, economic development, all ranks at the bottom of this. That doesn't mean that it's not happening. It just means that planners aren't reporting that it's occurring. And so I think Chris had mentioned earlier, there are actually a lot of studies that have kind of conclusively shown that there is an economic component to heat impacts. So that might be another opportunity area to kind of increase awareness about. Next slide. We asked what types of heat information sources they were using, which is in the orange, and then what types of information sources they're not using because they deemed them unavailable. So again, this doesn't mean that they're actually unavailable. It's just what the planners reported not having access to or not knowing about. I think it's not surprising that vegetation, tree maps were highly ranked, heat index, historic temperature data. So that kind of mirrors what we see in other climate change and urban planning studies. Then kind of further down the list, things that we need to improve on nationally. Heat vulnerability maps are deemed not available to many communities. Land surface temperature maps are deemed not available, and then future climate scenarios and even climate projections are kind of deemed as not accessible or available. So again, this kind of mirrors other urban planning climate change studies, but it looks like, at least from our survey, that planners are kind of relying on past experiences, so that historic temperature data, versus looking in the future for projections and future scenarios. So that's another area of opportunity that we need to focus on. Next slide. So I'll go through this really quickly. I think most of the speakers have covered almost all of these areas. This is in the paper that we wrote, just looking at different strategies to increase heat resilience. On the top half of the sun, we have heat mitigation, which we've heard a lot about. So again, kind of land use, urban design, looking at increasing urban greening and decreasing that waste heat. And on the bottom is the heat management strategy. So thinking about energy accessibility and reliability of the grid, things to decrease personal heat exposure, whether it's through those new OSHA standards that the federal government's recommending, or increasing awareness with hikers so that they don't go out on trails here in Arizona during the hottest times of the year. Public health, and then emergency management, of course. And so the idea here is that we need to look at all of these comprehensively. Next slide. So we also asked, of course, which of these strategies cities were using currently. And those heat mitigation strategies are same to the previous graphic. Those are orange on top, and then the heat management strategies are red on the bottom. I think this confirms a lot of the literature that's out there, that urban forestry is really seen as the silver bullet for kind of taking care of heat in cities right now. There's a lot of reasons why that is. I think Jane did a really good job of making the case that we need to look beyond just planting trees. That's one potential tool, but not the only one that we need to look at. I think as a planner, one of the things I'm concerned about is that regulations was only 24%. And we asked this question a different way, and it actually ranked even lower. So I'll talk about that a little bit more later. For heat management strategies, emergency response was the highest ranked, which has some implications because heat is often looked at as more of an acute risk. So looking at heat waves versus chronic heat, which for both Arizona and Florida is often more of a problem than those heat wave periods. And I think the other thing that concerns me, at least again, at the bottom of that heat management strategies, is that vulnerability assessments are pretty infrequently used, and staff, dedicated staff just looking at heat, whether of course it's a chief heat officer or anybody that has heat kind of in their job description, was one of the least deployed heat strategies. Next slide. So we asked about barriers to heat planning. I won't get into this too much. These are pretty common across any topic that you asked governments what they were having issues planning for. So I guarantee that we would have the same types of responses if it was for COVID-19 or flood response or something like that. I am doing a different study with interviews, so deeper dive into these cities, asking them the same question, what types of barriers do they have for heat planning? And that separate study, one of the things that's coming out, apart from these kind of more generic responses of funding, time and staff, higher priority issues, is that the framing of heat as a climate risk is something that a lot of local governments are really struggling to do appropriately. So I think that's pretty interesting, but these are pretty typical across all climate change and urban planning issues. Next slide. So we did ask what plans address heat, and I'll go through this pretty quickly. 65% of the communities were addressing heat in some plan. The most popular plans were any of those related to sustainability, climate action, or resilience. But again, if you look at the bottom, those building codes or zoning codes were under 25% of this response. And so again, there's no one plan that's kind of heat is living in. So it's across a lot of different plans, but we're not regulating the built environment for heat. We're planning for it, we're putting policies out there, but we're not actually regulating new development or redevelopment for heat very often in communities across the United States yet. Next slide. So just conclusions, most planners are already concerned about heat. 80% of planners said their community was already impacted by heat. A majority of planners reported addressing heat in some plan, but not using development regulations yet. Many communities implementing both heat mitigation and management strategies, but few communities reported providing utility assistance or conducting vulnerability assessments. Next slide. So one of the things I mentioned from the survey is just this idea of plan integration. And so as the survey showed, there wasn't one plan that kind of stood out as the plan that a lot of the heat stuff was going into. So this idea of plan integration is that it's not just one plan that informs the future of the built environment, but it's really the whole network of all of those plans and how they work together. Next slide. And so you can see here, there might be a parks and recreation plan that calls for increasing greening in certain spaces, which obviously has some heat mitigation benefits. Next slide. And the climate action plan may call for additional solar panels, which, as mentioned before, can provide shading both to parking structures or to potentially pedestrians or buildings, and may call for things like green roofs and green walls, which also have heat mitigation benefits. Next slide. But the transportation plan may call for increased roadway widths or increased parking lot sizes. And so while those other previous plans may be doing things to decrease heat, the transportation plan, this fictional city may be unintentionally increasing heat in some of those same places. Next slide. So again, it's just the idea that it's all of those plans working together, and we very infrequently have the time or kind of the resources to look at all of those plans laid on top of each other to really see how they're all working together to inform the future urban heat island. Next slide. And so just mention quickly, I do have a NOAA-funded project with, again, Sarah Miro, Philip Burke at UNC, and then Joseph DeAngelis at the American Planning Association, where we are looking at a process to lay those plans on top of each other and spatially code them so that we can see what the community's plans are actually kind of informing their future built environment. And we're working with pilot communities, Baltimore, Boston, Fort Lauderdale, Houston, and Seattle. And this builds on work from the Plan Integration for Resilience Scorecard for Flooding that is at mitigationguide.org. So we'll be developing a guidebook and a book that will be free and publicly accessible with the American Planning Association. Next slide. So just to wrap up, and I know we're running out of time, I'll wrap up with some final closing thoughts from a comment piece that I was the lead author for that was published in Nature, looking at deploying heat officers, policies, and metrics. And really in this article, we were calling for more attention to heat governance, which we define as the actors, strategies, processes, and institutions that guide decision-making for mitigating and managing heat as a hazard, with again, that idea that Well, we have, FEMA floodplain maps and, entire infrastructure to fight wildfires that's deployed in the West. We don't have the same kind of national or local infrastructure to deal with heat in the same way. And so we're really calling for more attention to kind of look at this governance structure that's quickly emerging and to make sure that we're doing it in a way that's evidence-based, equity focused, and getting those best practices and those lessons learned out to all communities. So it's not just the large cities with the resources to deal with them that are kind of moving forward. So we have 6 principles and research for researchers and decision makers. And again, I'll go through this pretty quickly. The whole paper is available at the link at the bottom. But we call for cities and governments to advance heat equity. And I think that's been covered quite a bit here. One thing, of course, is that a lot of the recent media attention has been on heat equity, kind of focused on land surface temperature differentials in neighborhoods and kind of their connection to redlining past historic inequities. And I think that's really important. But as we also heard, heat inequity is much more systematic than just land surface temperature and involves access to healthcare, kind of your employment situation and workplace safety, educational place safety, your transportation, whether that's safe and reliable, and of course, whether you have access to accessible energy and indoor cooling. So kind of looking at all of those is really important for heat equity. For heat mitigation, we've heard a lot of different strategies today on how cities can mitigate heat in the built environment. I think, again, I'll point back to, we're kind of looking at forestry and urban greening strategies as a silver bullet. And I would say even those cool pavement treatments are increasingly popular in a lot of cities. But the one thing that I would call attention to is that those are often taking places in the public right of way, so streets or in parks. And we're not regulating the private sector or the private private property with land use regulations and zoning codes for heat. And there's a lot of reasons why we're not doing that I won't get into now, but kind of looking more at how we regulate the future built environment is a really important component of that, because that makes up a large proportion of what contributes to the urban heat island. So just an example from Tucson, we passed a new accessory dwelling unit ordinance to help increase affordable housing accessibility. And one of the requirements in that was all of those new ADU units would actually have a cool roof required with them. And so kind of looking at integrating heat is just one of those normal things that we regulate new development for. Of course, managing heat's important too. And we'll go through this quickly, but there's been a lot of attention to heat waves particularly. And of course, the Pacific Northwest heat wave killed over 1,200 people across the United States and Canada. But I think it's, as was mentioned earlier, the regional differences in how we manage heat is really important. And in 2019 in Arizona, 80% of our heat deaths came from outside official heat warning periods. And so that's more similar to Florida, where heat is a year-round or a summer-round certainly issue, and not just a heat wave issue. And so kind of thinking of those regional differences, and again, not just focusing on those typical heat management strategies like cooling centers, but kind of diving a little bit deeper. And again, the only reason that we need cooling centers is because portions of our population do not have safe housing to live in. And I think until we answer that safe housing question, the cooling centers will be a Band-Aid. And so, if we need that Band-Aid, that's fine, but let's address the root issue that we don't have safe housing for a lot of our population in the United States. Developing consistent metrics across urban planning, public health, emergency management. Of course, I mentioned coordinating initiatives across that plan integration idea at the local level, but then of course across government scales too. So the state and federal government have a really important role to play. And then of course, building heat institutions is critical. And it's really exciting to see Jane Gilbert as the world's first chief heat officer. Phoenix, of course, has the first publicly funded Office of Heat Mitigation and Response. And Los Angeles this Wednesday is putting up a vote if they're going to have a chief heat officer too. So I think those are really important steps kind of in advancing heat governance. But again, there's a lot of medium-sized and small-sized communities in the United States. So 20,000 local governments in total that will not have the capacity to have a chief heat officer or a dedicated heat office. And that's again where regional institutions like the Southeast Florida Climate Change Compact are really critical, but then also that state and national support is really critical as well. Next slide. So I'll wrap up there, Lauren. Again, feel free to reach out to me at lad@arizona.edu, and happy to send along any of those papers or discuss this further.
Fantastic, Lad. Yes, I know folks were writing into the Q&A that they were interested in links to the papers and preprint. So if you want to share those with us, we would love to disseminate them. I know we're creeping up here on the hour, and I hope a few folks will be able to hang with us just for a few more minutes for some really great questions. Such interesting research, Lad. First question, someone notes, it's already a really large challenge to integrate in the built environment energy efficiency, renewables, sea level rise here in the case of Southeast Florida, whether through regulatory frameworks or incentives. What do you see as sort of the first step in bringing this all together, including extreme heat in a holistic way? And I guess, where you've seen this done well, is there sort of and I'm being tongue in cheek here, but like a secret sauce that's local governments have?
Yeah, no secret sauce, unfortunately. I think starting with what you have and kind of recognizing what you have is really important. And so I would just say that, so Kurt mentioned there's kind of frameworks out there. We're going to build the framework with the American Planning Association that kind of categorizes different strategies that communities can use. But I think it'll always be a little bit of a suite of strategies that communities have to pick from based on their local climates, kind of what's locally relevant and local values. And so, choices like here in the Southwest, urban forestry may even be less attractive because we also are in a mega drought and have to think through water considerations. And so kind of weighing all of those things locally is really critical. But I would say there's actually a lot of things that cities already do that have heat mitigation benefits. And so any sustainable building codes or energy efficiency building codes have a waste heat reduction component. And the same thing with any kind of walkable communities or increasing transit use or bicycle use also reduces that vehicle waste heat that contributes to the urban heat island. So I think part of it is introducing new strategies. And the other part is recognizing those current strategies that we're doing and kind of saying like, hey, they also have a heat co-benefit. Let's talk about that more publicly.
Really good point. Really good point. I also love the point you made about getting to the root of the problem rather than thinking about offering those kind of band-aid solutions. I was interested to see that regulations in general, regulating the built environment wasn't really seen as a kind of a top priority or strategy that's currently being used by planners in your study. I mean, why do you think that local governments why is this a barrier? Or why are folks not seeing this as a stronger tool in their toolbox? And to what extent do you see there being sort of more levers, through state building codes? Here in Florida, we have a super strong building code around wind and hurricane. I'm interested to hear how kind of heat could become part of that.
Yeah, so I have a few hypotheses that are kind of supported by that deeper interview study that we're doing right now. So one of them is that heat does not damage the real estate sector in the same way that other physical climate risks do. So the real estate sector has property insurance and is very attuned to wildfire risk and flood risk because it literally can destroy the properties that they're investing in, right? So heat does have physical impacts on increased energy use and water use. And it can damage like physical infrastructure too. So we saw in the Pacific Northwest, some of those transit lines kind of melting off or the roadways buckling. But again, those were public sector impacts. Like the private property sector, real estate development world doesn't care about heat in the same way because it doesn't have the financial kind of component to it. So I think it makes it a harder case for local communities to regulate the private sector when the private sector doesn't have like a kind of a foot in the game. And so that's why I think that economic argument is something that we have to work a lot harder on to make it clear that there is actually like an economic component to heat as well. So I think that is a large reason why communities are largely gravitating towards kind of urban forestry, things in the right of way like cool pavement versus regulating the private sector. Another reason is, again, for flood risk, we have the whole entire national infrastructure for FEMA floodplain maps. And as bad as those actually are, because they aren't accurate and they don't include climate change protections a lot of the time, it still provides kind of the national assurance that local communities can regulate based on that. And if people have a problem with it, it's not the responsibility of the local government, it's the national government that kind of takes on the onus of backing up the data or changing the floodplain maps. And so kind of the fact that local governments are largely on their own with regulating heat makes it a little bit trickier for them to work with the private sector and kind of impose new regulations. So that doesn't mean it's not impossible or we shouldn't do it, but it's just going to be a little bit of a different conversation.
Right, right. Finally, and I think I want to address this because I wouldn't want I wouldn't want you to be misunderstood, and I don't think that this is what you were necessarily saying. But somebody said would be interested in your thoughts on how we move on from cooling centers as the solution. Human Rights Watch found in Canada that they are often least accessible to the most in need, or have officials already moved on? I'm not sure that's what you were saying, so I just want to give you a chance to address that comment in question.
Yeah, so I think we do need to improve cooling centers. And so a lot of times the information about how, where they're at, what their hours are, whether pets are available, it just isn't reaching the people that actually could use them. So people experiencing homelessness, or those that are kind of in their homes without adequate indoor cooling. So I think there are things that we should do to make sure that cooling centers that we have are kind of placed in the right places, more accessible. But a lot of times they're only operating during heat wave periods. That they close at nighttime, and nighttime temperatures have an impact on health too. So that's why I'm largely framing those as maybe a necessary band-aid for now, but we really need to address people's housing safety as the foundation for kind of thermal equity, versus like putting all of our resources into more cooling centers. And I think there's a lot of other things tied to the housing crisis that we have right now, but as long as you have people experiencing homelessness on the streets and the number that we do, no amount of cooling centers is going to protect all of them. So
absolutely. Well, fantastic, Vlad. I would love to, in particular, keep in touch with you related to some of the information you found in the survey related to some of the gaps or perceived gaps in information. That's a place where the compact really tries to lean in and help bring resources to bear, or at least highlight resources that exist for the local governments and other practitioners across the region. So I'm really interested to hear more from you about that. Thank you again so much for sharing your research with us and your expertise. We so appreciate your time, Vlad.
great, thank you so much, Lauren.
So with that, I just want to close out today by again thanking our speakers and those who joined today's workshop. I know it has been a long day. Really appreciate so many of you hanging in there with us and for your interest and participation, as well as the really important work that I believe that all of you are already doing towards addressing heat as a critical climate change threat in our region. I also just want to reiterate my thanks to the planning committee who helped design today's event, and of course my colleagues who are behind the scenes and made this possible as well. As a reminder, we'll be posting a recording of this workshop and all the presentations on the Compact's website in the coming days, as well as distributing links to all attendees via email. We really do look forward to additional feedback about today's workshop, and we'll be sending out a very brief post-event survey that we'll hope you'll take 2 minutes to fill out and offer your perspectives. Your feedback truly does help us to continue to improve future implementation workshops and ensure that these workshops are designed to meet your needs. So thank you very much in advance for your participation. Thank you all, and I hope you have a wonderful rest of your day. Take care.